going to help to grow towards that. Now, if I understand the spiritual journey or textual things, which has given us the practical guidance for the sustainable practices, you will be seeing that how powerful we are. Just going to the next slide, if you see, there are Vedas, Upanishads, Arthashastra, Rasashastra, Rasaratna Samuchaya. All these are talking about metals and mining. It is really just unbelievable thing when you think of going to the Rajasthan, where Jawar there is a mining, there is a zinc mining, which is in the century of 1200 century. There you can see we are talking about industrial zinc mining in the year 12th century. So this is a miracle for Indian history, that we are deeply connected through our roots. Now if I go to Rig Veda, if you read, Rig Veda is talking about metals as a cosmic gifts. If you read that, Tasmat Rajanna Suvarnam Ajayate, from him arose gold for the kings. This shows that gold was not only merely a wealth, it is also sacred. It also mentioned that Aya Sringam is iron horn. The reverence reminds us the metal must be respected, not wasted. See, nowadays India government has come up with critical metals. You talk about rare earths, lithium. These are all critical as well as finite. See, Rig Veda has pointed out that. It has pointed out that the metal is sacred, also not to a greedy part of it. Now if I go to the Samaved is generally, it talks about musical things, purely musical thing. It's to, there also in the Samaved, there is also a mention of metals. If you see, Indraya Hiranyavan. Indra is a god, a Hindu god, which is a possessor of gold. This connects metal to divinity, showing that resources are tied to dharma, not greed. In fact, if we talk about our ESG thing, where you are talking about ethical mining. See, Samaveda is talking about ethical mining. It's not that you will be the possessor of the gold. You are supposed to be trustee of the metals. So that way, it is only when you are aligning the mining with dharma, that is ethical mining, then only you will be able to survive, you will be sustainable. Now, another Veda. There are 4 Vedas, Rig, Sam, Yajur and Atharva Veda. I am talking about Yajur Veda. Here, you can see that Hiranyam astu may be the gold for me, but invoked by the reverence. Aya Sirus, iron-headed weapons. See, here it is talking about duality of the metal. See, metals can be useful, also can be dangerous. Now, if you talk about, nuclear technology, it can power a city, also it can destroy a city. So there is a duality in the nature, and our Yajur Veda has recognized that. It shows the metal can be useful but also dangerous, and similarly, if you see the sustainability link, it is talking about the use metal responsibly, avoid harm. Now, I will come to the Atharva Veda. Here, it is a direct most directly it is talking about Mata Bhumi Putra Ham Prithvi. Earth is my mother and I am her son. The hymns also talking and telling miners to take that without injuring the earth. Earth is our mother, so you should not injure or harm the earth. It also tells that earth as divine, finite, and worthy of protection. See, modern mining system, if you mine earth and after the mining you just go out of it. So restoration of land reclamation of these has to be done to keep our earth in a proper way. Otherwise, you are going to harm the earth. So it is talked in the Atharva Veda itself. Now, if you come to Upanishads, here you see the Upanishads have it has given the philosophical foundations. Ishavasyam idam sarvam. All is pervaded by the divine. Do not covet. Sarvam khalvidam Brahma. All these is Brahman. So this emphasize the unity and the stewardship. Now it exactly resonates Mahatma Gandhi's trusteeship principle and also the modern ESG ethics. Directly it is relation. You can see. Now, if I come to Rasa Ratna Samuchaya, and this is one of the important document of Indian, history, where it is a text. It is between 11th to 13th century, and it is talking about ancient metallurgy. Now, it is talking about I can't see that, metallurgy and mining, mineral classification, extraction and purification, sustainability in metal use, alchemy, which is Rasavidya, and medicinal applications. Now, you see, when you talk about material classification, you can see that there is Maharasa, which is primary minerals, second is Uparasa, which is secondary minerals, and Sadharana Rasa, which is common minerals. So, the need of classifying the metals is very important, and it has been given in our Indian scriptural things. Now, it is talking about, if you see, there are mining practices. If you see that the verses like Loham Suddham Bhavet, Karyam Rasanam Yoga Muchyate. I think it is there in the next. This is talking about that. It is talking about the purification and calcination of metals. It is also talking about the ancient version of ESG, material must serve the society, not harm it. Now, all the plants are talking about zero discharge and the recycling. It is similarly usage of waste. In the morning, people were talking about usage of slag into road making, usage of slag in different kind of uses. So this is what our scriptures has already recognized it, and it has been given to us. Only thing is we have to understand this in a proper way. Now, if you see, this is a philosophical foundation. It is talking about Divya Dravya. It is divine substance. The metals are divine substance, and it has to be used for Lauka Kalyana. It is welfare of the world, not for the greed, loha or harm. So you should not use the metal not greedily. You want to be greedy, then it will be harmful for you. Only thing is that it has to be in a proper way, ethical way, and it is directly connecting with the modern ESG, environment, social and governance ethics. Now, these are all famous verses where where Rasayanam hi nama rasayasya ayanam tena sarva roga vinashrati. It means Rasayana is proper channeling of marketing, and by it all diseases are destroyed. Implication, if used properly, the metals and minerals can heal, not harm, aligning with the responsible usage of mining and metallurgy. Now there are other words you see, loham suddham bhavetkaryam rasanam yogam. It is the purification of metal, or loha is iron. So it's a purification which is aligned with the environmental safety. Now, if we see that there are other mentions in the Arthashastra which is talking about locating mines, managing resources, preventing over exploitations. Agastya Samhita talks about mentions zinc, lead, copper. Rasi Shastra, it talks about smelting and alloying, and it is directly responsible extraction for dharma and the society. Now, if you see, this is totally a Arthashastra. It is talking about khanijani sampatte moolam rakshani parikshani yatnani cha ananiya. Mines are the root of prosperity. The mines are root of prosperity. I think everybody can hear it. They must be protected, inspected, and carefully worked out. See, this is directly, you see, ancient India, it has recognized the over-exploitation of natural resources. And it threatens the long-term prosperity. So, Arthashastra has really and has pointed out that it has to be properly, ethically used. Now, if you see in Arthashastra, you see it has talked about Arthishu Sthaneshu Suvarna Rajata Rupya Tamra Kandaka Shisha Trapu Lauva Manikya Vaidilya Gomeda Vajra Shankha Mukta Srila Upaya Jnanasya. See, this is the metal. It has talked about, Arthashastra has talked about, these are the metals, gold, silver, copper, lead, zinc, everything we are mining now. Everything is being mined. So, it has to be mined in a proper knowledgeable way. And it has to be given, you see, the superintendents have been knowledgeable about the methods and locating and extracting them. Here, the superintendent is the owner of the mines. It's the companies. So, it has to be properly planned, the mining has to be properly planned and ethically calculated. Otherwise, we are digging our grave. Now, you see, Arthashastra really has a chapter. You know, you see, in the book 2, in chapter 12, is talking about Oipanika Adhyaksha, superintendent of mines. It is talking about, let us suppose you take it as a mining ministry. So, it has to be in a proper way. The sustainability foresight is guidance to avoid over-exploitation, ensures worker safety, as well as prevent state losses. It is, you know, if you see, it is talking about resource management. Already, you know, I have been given 2 to 3 minutes. I'll just complete first. Just I will go to the next slides. It's the relevance. There are big relevances of ESG. If you see SDG 12, responsible consumption and the production of it is very directly relevant into it. Now there is Agastya Samhita. I will not go into it. There is Rasa Shastra. It is talking about our sustainability link. There is a responsible extraction which is given by the Dharma. It is talking about SDG 6, SDG 7, SDG 14, 15, just everything. You see, the first line, the entire SDG framework is designed to improve the human well-being. All the 17 SDG program which has been taken by United Council, this is directly for the human well-being. And in our Indian scriptures, it is directly related, and they have given the guidance also. Now there are, instances where we have done excel. You can see that the iron channel of Delhi, wood steel, these are all, usage of our brilliance which we have been there in our ancient days. So this is directly connections of modern sustainability with the ancient insight. Direct, there is a huge connection. They are talking about circular economy. It is talking about hazard prevention, ESG principles, so many things. And they are talking. They are in our scriptures, Prakriti Purusha, which is nature and human harmony. It is talking about cosmic ecological balance. There are minimal waste and circular usage also. This is directly related to the modern mining industry as well as there is a sustainability framework, and these are the companies. They are already abiding by these rules. I think even in Chhattisgarh and Odisha there is a sustainable mining practice. So at the end, what is the way forward? There is ethical mining. It has to be there. It has to be balanced with dharma, artha, and prakriti. Digital mines with AI and renewable energy, which is modern Rasavidya, and sustainability as civilization responsibility. All of us are responsible. Just so in conclusion, I just wanted to tell you that India has taken a NDC where we are talking about net zero in the year 2070, and to go into that, while strive for going for the net zero in 2070, we should not harm our Mother Earth. We should take care of our Mother Earth. May the earth be saved. May we all be saved. Thank you.
Thank you, Dr. Majumdar, for your fantastic session. Next, I will invite Dr. Satish Kumar. Dr. Satish Kumar is a professor of mechanical engineering at NIT Jamshedpur with over 20 years of teaching and research experience. He earned his BTech and MTech from SV NIT Surat and PhD from IIT Roorkee in solid liquid flow. He published more than 176 publications with research focus on slurry rheology, CFD, erosion wear, and multi-phase flow. He has completed 7 funded projects and 4 projects is ongoing. He has organized multiple conferences and FDPs. Currently, he is a Dean of Research and Consultancy and NIRF Nodal Officer at NIT Jamshedpur. He is a life member of several professional societies, and he has been listed among the world's top 2% scientists by Stanford University. So now I invite Dr. Satish Kumar. He will give the presentation on the topic mineral characterization, utilization, and transportation characteristics. Over to you, sir.
So good afternoon to all. Thanks, sir, for nice introduction. And before the talk, first I congratulate to the Vice Chancellor and organizing team for organizing such nice conference. Also, I thanks for giving the invitation for me to Vice Chancellor and Kalyanji and his team. Now I am here. So I am here for the 2 purposes. One is explore our area so that we can make the contact with you, either the undergraduate level or the PhD scholar level or the faculty level or institution level. So okay. So sir has already given my introduction. These are my area of personal expertise. I am working in erosion wear, computational fluid dynamics, rheology of the multi-phase flow also. And with the help of the several DST and SERB and other research projects, I able to develop this some facility. In main facility is I have developed the 65-meter pilot plant test loop for measuring the solid liquid flow, pressure drop, performance of the pump with the different bends, different type of the configuration of the pipes and other things. Also, I have tried to develop for This is conference organized by the Metallurgy and Civil Engineering Department. So, two erosion testers, slurry erosion tester as well as the air jet tester. So, I am working also the coatings of the materials of hydro turbine, thermal power plants and others. So, I am here for, we can make the collaboration with the exchange of the faculty, students, organizing the conference. I am a nodal officer of the institute also. You can get my email ID from institution level. I approached to the two foreign collaborators also with the OP.jindal. We can go ahead. As students level, you can invest your time in my institute in winter vacation as well as in the summer vacation, 1 month, 15 days. Try to mail me with the help of your mechanical engineering faculty or the nodal officer. I can provide the platform with the NIT faculties, either computer engineering department or with me computational fluid dynamics or any other areas. Comes the topics of the discussion. I am working on the several projects completed related to the ash disposal system and waste processing, mineral waste processing. So, this is the outcome of the, this is the discussion of the one of the project. Currently, thermal power plant, you know, in the thermal power plant, coal we are using as a fuel, and after burning the coal, we are producing the fly and bottom ash. So, large number of the fly and bottom ash continuously produced by the thermal power plant and very difficult to consume continuously. Ministry of in Government of India and thermal power plants also makes the various initiation to utilization of the waste produced by the thermal power plant, and finally we are able to utilize 55-60% of part of the ash only. Rest of the part of the ash you have to transport into the ash pond nearby the thermal power plant. So, what we are doing, I have visited the Jindal Power also 2-3 times for when Katre Sahab was there for getting discussion of the one of the project problem in the thermal power plant. So, what is the problem of the thermal power plant? They are mixing the water with the ash and try to dispose by using the pump and pipeline to the ash disposal system. But you know the sand is, as having the settling characteristics properties. So, after some distance they become the settled down. So, finally outcome is you thermal power plant able to transport the ash from the ash handling unit to the ash pond with 10 to 20% solid concentration. Meaning is that for transportation of the 10 kg of the ash, power plant using 90 kg of the water. With the help they able to transport into the ash disposal system. Second problem is in civil engineering department, many professors are working in environmental issues. So, when the large amount of water goes into the ash pond, then the from the you can say fly and bottom ash, mineral content trace down and goes into the water. And you have seen the many news from the nearby the thermal power plant area, affected with the cancer and other things. I am not going to detail. So, these are the problems. So, my work, my discussion is how we can go ahead, how can improve the transportation solid concentration with the moderate concentration, so that we need the less water to transport the ash from the ash handling unit to ash pond, and also we can consume minimize the water also. So, first part is I will try to complete within 20 minutes. So, first part this discussion also can take the BTech student for their projects also. So, first this is the fly and bottom ash collected from the thermal power plant, and you know the as a mechanical engineer or metallurgy, you are doing the some physical and chemical characteristics. So in physical, specific gravity means density calculated. For fly S, this is a 2.1 and bottom S 1.94. Similar, sorry. Then next is particle size distribution. Particle size distribution we are doing for analyzing the how much finer particle or different range of the particle present into the your solid contents. So fly has found the more than the you can say more than 37.2 S particle are coarser than the 75 micron, and only 17.35 particles are lesser than the 53 micron. Then, as I have already discussed, when you are transporting this ice with the water, then settle down in the pipeline. So you have to conduct the settling characteristics. So initial concentration was taken 20 degrees Celsius, so 20 percent solid concentration, and these are the final solid concentration of the ice. Meaning is that maximum fly ash you can transport up to 60%. Similar, this is applicable for the bottom ash also. pH also we are evaluating, doing the test for evaluating the you can say chemical characterizations for the measuring the reactive nature or non-reactive nature of the your solid particle with water or given in any liquid. Then same characterization, same result shows that the fly ash particles are the very smooth surfaces and having the spherical morphology. Spherical morphology's name as in engineering terms, it is known as sinosphere. So maximum number of the sinosphere presents in the fly ash particles, and bottom ash particles are the coarser in the nature. Then the chemical composition of the fly and bottom ash shows that the silica, aluminum. So aluminum oxide present 35.58 and silica present 44.90 in fly ash, similar in the bottom ash. And when you combining the silica and aluminum, and when your addition comes more than 70%, then civil engineering engineering professionals name as this is a F type of the fly ash. And F type of the fly ash shows the very good pozzolanic property of the your ash. So this is the leaching characteristics I am not discussing, as I have this leaching characteristics we are performing for doing the analysis how much percentage of the your mineral contents traced down in your the metal contents traced down in the water from the your ash particle. So this performance shows also the some just you see the zinc, molybdenum, cobalt shown at the under prescribed limit of the WHO, as well as the other components are in the normal range. So this is test conducts for the you can say getting the information about the environmental hazards of the ash disposal system. So finally, conclusion up to this topic, this discussion is fly ash having the F type categories. This can be used as a replacement of the cement. In this result, you know the all maximum thermal power plant, some part of the ash they are sending to the cement industries and directly they are mixing with the cement they are using. Second thing is when we are you can say doing the particle size analysis and maximum number of the particles are the spherical in the shape is known as the senosphere. So senosphere can be utilized for making the different type of the industrial products, and now you are getting in the markets. So this is the applicability, and the bottom ash having the coarser in the nature, so you can use for the brakes as well as the replacement of the geotechnical purposes and other purposes. And Chhattisgarh and Jharkhand are the mineral states. So fly and bottom as having the pozzolanic property again. So this can be used as a substitute of the sands in the mine. Because when you are getting the coal from the mine, then your next work is stowing operation, filling the sand in the mine. So at the place of the sand, getting the sand very difficult for the stowing operation. So this as also you can use as, because this is a very having the very good cementing properties. My team is already doing for that how we can design the pipeline and other things for the stowing operations. So these things also can be done. So this is the one part. Second part is how we can go for the high concentration so that we can minimize the water consumptions as well as the power. So next part is the rheology, viscosity measurement of the solid liquid of fly and bottom edge. So I have conducted the experiment up to 60 concentration. So this result shows that up to 30 concentration, this behavior is up to the non-Newtonian flow. When you are moving above the 30% concentration, then this shows the non-Newtonian nature. Maybe pseudoplastic, maybe Bingham plastic. I think fly and bottom edge both shows the Bingham flow characteristics. Then you have to use some additives for the improvement of the viscosity, or you can say transportation characteristics, so that you able to transport the your solid with the high concentration, and you able to save the your settling problem you can solve, and also minimize the water consumptions, power consumptions also. So we have added the sodium sulfate as a additive, because this is a soap solution. When you are adding, then this able to improve the intermolecular you can say forces between the solid particle as well as the sulfate, and in between also, so that we able to reduce the viscosity of the whole your solid liquid suspension. So this is the results for you can say addition of the sodium sulfate as a additive in your the solid liquid suspension. So 0.2%, 4 and 6% by weight we have added, and found that when you are adding, then the decrease the viscosity just you saw, and found that when you are adding the 0.4% of the you can say additive, then you are getting the optimum viscosity reduction in this case. Then next part is evolution. This is the pilot plant test loop diagrams performed. This is the two hoopers. In the hoopers we are adding the solid with water, and with the help of the pump we are flowing in the whole sections. Then you able to measure the in horizontal direction pressure drop as well as on the bend, convergence, divergence, in different sections you able to measure. So this is the experimentation with addition of the pressure drop. So pressure drop also shows the results, good results as the given by the viscometer or rheology of the solid liquid suspension, and here also we are getting the optimum decrease of the pressure drop in the pipeline with the 0.4% of the sodium sulfate. So this is the outcome of these two works. First I want to say here many BTech students are sitting. So in my presentation, one work is related to the mineral characterization of the ash. This is a mineral states. So nearby you can collect the iron ore, you can collect the coal, you can collect the ash, and similar type of the investigation you can do for the final year projects also. This type of the work also you can MTech scholars also can proceed. Second type of the things is CFD simulation of the pressure drop pipeline Also BTech final year and MTech and research scholar also can take as a projects or as a part of the thesis. Here now the days machine learning is very famous. So machine learning as a also tool you can use for how you can optimize. And main outcomes for the what I have given in my research projects to the Ministry of the Science and Technology to that, without doing any modification in the plant, we can improve the transportation characteristics of the pump and pipeline so that we able to transport the same as in previously you able to transport up to 15, now you can transport up to 40% approximately, and you able to you can say minimize maximum of power consumptions as well as the water consumption. So this is my discussion. If you have any query, then most welcome. Yeah.
Now the session is open for discussion. If you have any queries, you can raise the hand.
Good afternoon, everybody. And my question related to you, you have given good model for this, how to transport from industry to safer way. So that is appreciable, but you have said in one statement that it has got many application in industries. So what are those many application? Is it for the steel industry, or it is a other core industries, or it is only the mining area? So that should be just is my query.
Yeah, good.
So that is one part.
And this is very good query.
Another part, second point, you have also mentioned that the irrigation. So after transportation, will it affect to the irrigation part or the villagers or not? So that also, what is the impact in maximum or minimum, tangible or intangible way?
Yeah.
So because it is the ultimately our aim to do any project which will good for the society. And our project is nowadays we are going for the lower environment. We have to always control the environment, keeping in by view.
Yeah,
Thank you, sir.
Thank you. So first part is this work, I have already told this work can be extended for the other minerals also, and total I have supervised related to the multi-phase flow 16 PhDs and 5 are ongoing. One of the faculty from OP.jindal University, Akash Pandey, also work in same direction, coal water suspension, transportation. So this work can be extended for iron ore. My PhD scholars already done the some work. We are doing the some work with the different type of the coal also. And then second thing is and three aspect in first slide I have already explained. Erosion wear also, characterization also, multi-phase flow modeling also, experimentation also. So if any opportunity related to the industrial problem, most welcome. I am ready to do this work with our team. If possible, then OP.jindal University is also my collaborative partner. So some part also can be done by the OP.jindal University. We can make the things. Second question was, second part was? Yeah, agriculture part of it. When we are, I am belong from the fluid engineering background, and I have done this. Suppose this analysis. So my result shows that by doing this transportation, characterization and experimentation, you able to transport your same as up to suppose 35 concentration. Meaning is that you able to save the 20% of the water as well as the similar you can say power consumptions also. This help to when this you can say moderate concentration of the solid goes into the ash pond, then you will get the you can say high concentrated less concentration of the water, with high amount of the ash. So metal tracing characterization will reduce. So this will able to reduce the environmental hazards. Chemistry people are doing some extent. I have done the leaching characteristics, tracing element characterization by using the different methods. So this will help to when we able to transport the same thing with high concentration. Amount of water if you reduce in the pond, then obviously tracing lower down and help to reduce the environmental hazard. Yes.
Okay, hello. Do you find any heavy metals present in the coal ash like vanadium, nickel, chromium, like
Yeah,
that?
I have shown, sir.
Yeah,
Three or
but,
four.
those can be recovered.
Huh?
Those can be recovered or not?
I have just done the leaching characterization, tracing element characterization.
Okay.
See how many metals are in the under limit and how many metals are the above the limit of the WHO.
Okay.
Just
Okay.
okay. Thank you for giving
Hello,
the
sir.
chance. Yeah.
Sir, at the starting, you have introduced us with the two problems in this regard. The first one is the fluidity. Because of that, we are restricted at the 10%. Then now, because of your work, I think it is getting somewhat higher, and we are reaching 40%. The second problem you have told us regarding the soaking of the minerals to the groundwater. In that side, any of the achievement you have done, like your team, something like how to restrict that soaking of
Yeah,
metal?
same things.
Okay.
Our team has done the analysis how our ash contents with the given concentration giving the environmental problem, and when we are transporting the same thing with high concentration, then how you can minimize. Because when your water amount is limiting, reducing, then the tracing, obviously tracing metal concentration will reduce. This able to reduce the environmental hazards.
Sir,
Other chemistry backgrounds I have
yeah.
not.
So, like, can it be a futuristic
Yeah,
work? Like
this
any
this-
kind of doping into that pond?
Yeah. And your chief guest from IIMT Bhubaneswar,
Okay.
some scientists also doing in the same direction
Thank you, sir. Thank you.
work. Okay, thank you. Thank you.
Thank you, Dr. Satish, for your informative session on minerals. Next, I will invite Dr. Ganguly. Dr. Subhash Ganguly is Associate Professor and Head of Department of Metallurgical and Material Engineering at NIT Raipur. He earned his PhD from IIEST Shibpur, and he held visiting scientist position at Iowa State University, USA, and University of Manitoba, Canada. With over a decade of academic and research experience, he has contributed significantly to physical metallurgy, alloy design, and computational material science, particularly through AI/ML applications. Dr. Ganguly has published 75 plus papers, book chapters, and one book with over 1,000 citations with an H index of 19. His recognitions include the Young Engineers Award from the Institute of Engineers and the Best Paper Award in Metallurgical and Material Engineering. His current research focuses on materials data science, advanced alloy development, friction stir welding of dissimilar metals, and AI/ML-driven high-throughput metallography. Now I invite Dr. Ganguly to give a presentation on the topic Steel Informatics as the future in solving problems of the iron and steel industry. Over to you, sir.
It gives some allowance for 15 minutes. Actually,
I'll be comfortable if I. Yes. And I want to use this PowerPoint. Our class rate is more than 100, so I'm very comfortable to talk without mic. If I'm not audible, the last row, please tell me. I will increase my volume. Hopefully, I'm reachable to you, right? Thank you.
All right. With this backdrop, I think my initial slides are no more important for after such a nice introduction. So these are the place and these are the people with me who are helping me, and these are the area where I am working. Not much relevant. Let us come to this content. We will follow today's this coming 15 minutes. I'll go like this: the introduction to informatics, as I'm going to talk on still informatics with the help of AI/ML. So, in that context, so I will start with some sort of understanding about informatics. Being a metallurgist, I know a little bit of metallurgy, less computer science. So here is an effort to second with our computer science friends and to do something with the metallurgy in true sense, the multidisciplinary activities. So let us look at how we will proceed. So we will start with some, I think my pointer is not working, but okay, fine. I will be happy with just to refer this slide. So we'll start with some introduction to informatics and especially steel informatics. Why informatics in steel and why AI/ML? And then I'll try to put up the things in context, that little bit of AML framework, little bit of introduction to AML. Many of us from the mechanical or metallurgical background, and if there are some computer science background, please bear with me, little bit of boring for you, but I will take your attention to introduce what kind of problems are there in the metallurgy and mechanical engineering where you can take part. And then some of my research contributions. So automatic recognitions of this phase recognitions and microstructure problem. So that we will introduce later on. And steel design, I will deal with a small descriptions of steel design, how to participate in steel design problem, how it can be addressed from the informatics perspective or AI/ML perspective. And then I'll little bit of my work in the area of blast furnace data modeling with convolutional graph neural network. It's another tool. And finally, I will try to conclude the thing. This much text I have just picked up from the wiki, just to introduce you the informatics. What is informatics? What I simply understand is that something doing with the computational things, you can refer as informatics. Here I am trying to use the computational things in still study. So I would like to refer the things as the still informatics. Anyway, I would like to explain it little more details. So what actually informatics, I understand, I try to assume it in this way, that there are plenty of data, whether it is in research data, whether it is in industry data. Data is somewhat the information. So that information is our beginning to work with. But don't worry that, AI/ML is going to kill everything, and AI/ML will be able to survive this globe without any support of the experiments and theoretical study and other study. No, that's wrong. As of now, it is taking the momentum. It is entering into the different engineering area where it is trying to utilize what our seniors, our ancient people in this area contributed. The earlier scientists already contributed. It's trying to integrate and to help you out that you can utilize the integrated knowledge done by many people, stored in your internet or stored in some form. You can utilize that, and you can try to make out of something more than what has been not done before. But okay, it's going to solve all the problems? No. If we're going to stop our research work in the laboratory, in a generation of the new data, if we stop our everything that is possible with the help of AI/ML, no. there are a very wise use of the technology, and we can work with that only, and with that we can proceed with. So as of now, we are feeling that everything will be done by AI. No, we have to continue to work with all those things. That will give us the new research data that will allow you to help to build the new model with the AI ML. So it's more like that. Okay, so I have not demonstrated. So we start with data, and my x-axis referring something which is actually difficulty. Difficulty of what? Difficulty of your data analysis tool you are going to use. Simply you can mean, median, and standard deviation and other thing you can just figure out. That is a simple analytics. And as you go ahead, this will help you to understand what is your data. This steps, if you do a little bit more analysis, this will give you what did it happen in the data, and you can look at the major part is AI/ML. So you want to build the predictive model, how this data is connected with other things, and then finally you want to prescribe something. I mean, you want to suggest to your industry, you want to suggest to your audience that with this you can do better. You can take this decision for optimizations of cost, optimization of productivity, or optimizations of, in particular, alloy design with some property and other things. So that we will see. Why steel informatics with AI/ML? I would like to take you through some small equations, very popular in the metallurgical domain. So this is Halbach equations. Just I would like to take your attention to this constant part, and some constants are there, right? Similarly, this is another carbon equivalent equations. Again, there are some coefficients kind of things. This is another critical temperature related to phase diagrams of iron and steel. These are all taken from some source. Andrew's formula for martensitic start temperature, martensitic end temperature, Benedict start temperature, Benite end temperature, and so on. This is again correlation between the YS and hardness, UTS and hardness. These are very popular. These are from certain, I'm sorry that the reference is not visible, but I have referred the paper from where I have taken. Now, what common there? If you look at how they came into the picture, all of a sudden, or some fundamental thermodynamics, or behind that some ab initio knowledge? No, they are just formulated from data. They are somewhat, and you can understand that how potential. It is more than 50, 60 years we are studying these Halbach equations, and now we are coming up with the new knowledge of particle and all. So the common is mathematical framework is assumed, and then people are trying to understand the unknown factors. So with this, there are plenty of such equations. Some of them are there, mostly empirical in nature. So these things are just common. So let us look at this picture, that what AI/ML and why we should do AI/ML in this domain. So see, the conventional computing, like your finite element, what are the things known? Your inputs are known. Your functions are known. So this is your stiffness function, right? But what is unknown? Unknown is your output. So it uses input, your model, and it derives some sort of solution. That means output. In contrast to that, in AI/ML situations, you have a lot of parameters which are known, variables, input variables. Output is also known in the form of a data. But what is missing? The missing thing is your model, correlations. For example, you have lots of composition and microstructure, but we do not know what is the strength of the alloy, strength of the steel, like that. So this is the summary of the same things, but I have told you that the available things in case of traditional, in case of things, and what are the goals. Let us look at AI/ML world. Nowadays, everybody, I guess, know, I need not to spend much time. There is one more subset within this machine learning. We call it deep learning, and it's going further. I don't know whether another subset will be developed or not. A quick framework. So framework of this, can I get a little bit of water? Yeah. So this is the framework. We start with some sort of presuming the model, and then we use the data, and then we try to look at the fitting with the initialize weights and other things, other unknowns, and then we evaluate the loss, and then we try to minimize the loss iteratively. And that's what the learning is. So in that context, this is the learning. So in machine learning, the first is you need a data. Second, let us look at the next. We need a model. We have to choose some sort of mathematical framework. We need data. Without data, no AIML. So first of all, we need data. We need a model, mathematical framework. We need to look at how we are going to define our unknown as a function of how I am progressing towards the correct fitting of the parameters. And then we are trying to apply some sort of optimization techniques, which is basically a learning process. Iteratively, it is trying to reach out to your correct value and so. And finally, we evaluate the model. Let us come to some applications, some of my research outcomes. So here, I'm trying to look at the microstructures of steels. And the thing is that the microstructures, let us look at this. What is microstructure? It is some sort of representations of chemistry, defect, and process interface, right? I mean, there's a vector space, all these three axes, and some sort of model microstructures I'm trying to show it. So this is actually decide the performance of the alloy. And I'm sorry. Look at this in this problem. So what is the problem? The role of microstructures in steel design problem. So if you look at what is the application, what is the set of properties, what is the grade, and then based on that we try to standardize the composition, then cleanliness of steel, the process parameter of steel, microstructures of steel, and many more. Now that decides a particular microstructure, and in this microstructure I want to take your attention here. Who did it? Ferrite. Who said us this is ferrite, this is martensite, this is benite, and written austenite. Without knowing it, you cannot confirm your quality. Those are industry background, the quality, particularly the quality people, they understand that steel quality. Every day we have to evaluate for every batch, every heat, the microstructures, and that confirms that whether your metal is perfect or not, or I mean, satisfying a particular grade or not, right? So who did it? That is a problem. So your phase identification is still human expertise based. The whole effort in this work is, can we substitute this human expertise? Can we make it in digital knowledge? That's the whole effort. So here what is trying, how to digitize this task. That's the challenge. Probably I have able to introduce you the problem. This is the model. First of all, we have to assume some sort of mathematical framework, and in that framework, whatever is unknown, we want to adjust that value starting with an initialized random values so that our objective can be, or goal can be achieved. That is the framework that we have introduced in the ML. It's a little complex, but believe me, if you sit with pen and pencil, you will be able to understand that what mathematically, actually how complexly you can write each and every constant and all those things. And it is nothing but if you start with an image, it will convert into some sort of your parameters value, and that parameters value will be able to reflect your property. So that's the stepwise some sort of things. What do we refer as nothing but your deep learning. So a deep learning model is assumed in this case, and we have used the VGG19, and how we have used the microstructures. We have collected certain amount of microstructures. In this work, it is about 300 steel microstructure, ACM micrograph was collected, and they have been trained, they have split it into certain species, certain sets to use for certain purpose, like you're building the model, testing the model, validating the model, and so on. How we have proceeds actually, your microstructure image, we segmented it with the help of certain technique. The Chan base is used in this case. And finally, we are trying to get some patches from each phases, small patches. and we have fixed up the size of the patches. It is 128 by 128 pixel for some reason. And then we have proceeded for all microstructures. We have plenty of microstructure we introduce, which are basically, some are dual phase, some are, like your trip steel and quench and partition steels and many other steels. So we have introduced all these steels in our database, and we receive the different patches. And these patches are trained with the model proposed, and the model learned, if you introduce a patch, it will tell you the what patch it is. And then it proceeds with the predictions. When you go for the prediction, again it removes the patches. And then for each of the patches, it first masks, it tries to understand how many phases are there. For each phases, it extracts the patches, and then each patches are predicted that these patches are basically martensite, ferrite, pearlite, or what. And based on that, it tried to scan your microstructures, and it said this region is benite, this region is ferrite, and likewise, it's annotate. So now, what is the outcome? Outcome is we could have a system where it can tell you that this is what kind of microstructure. Your microstructures is now in silicon knowledge, you can predict it, right? Of course, some of the diagrams I'm going to skip because I have a couple of more examples if I can touch it. So these are some sort of predictions and some misclassification, why those misclassifications happens and all those study. Some results. This is unpublished, but very soon the paper will be published. It's under considerations in computational materials engineering science. So this is again, I'm showing the results that how it's going to proceed. It started some microstructure, it's masking the different region, producing the patches and trying to predict it. And you see this is the probability that the phase, there are two phases. One is masked here, one is masked here. So you can see that what is the probability that each phase is like this. Okay, so let us move on. This is another result. And finally, we wanted to compare with our result with the other results. So once the phases are identified, then what is the phase fraction? So we have got this kind of result. This the in-between thing is R1. So you can see that yellow one is the R method. So it is very consistent with the quantifications done by the others. So which give us the confidence that our result is quite correct. Yeah, still design problem. Another, I have 2 minutes, right? It's 18 minutes or 15. Okay, I'll finish in 1 minute. So this is another diagram. So another challenge. We wanted to optimize the things. We fit it in the same framework. And you see data, then we are going to look at the data, what this data is, then we are going to look at the model, then we are going to look at the some sort of outcomes. So let us look at physical model. This is already exists in the literature. What we have developed with the help of the ML, we have developed this layer, because this is absolutely uncontrollable parameters. So these parameters are required to understand the elongation and UTS of a strip steel, provided these parameters are known. But these parameters are every cases, it's not dependable parameter or controllable parameter. We have developed a controllable parameters, and we make a fuzzy layer, and that layer is now, if you have these things, the heat treatment parameter and composition, it will tell you what is the strength of the steel. And using that theory, we have developed some sort of optimization interface, and we have designed the trip steels, and these are some sort of results. We come up with this kind of things can be good for the better strength and ductility. I'm sorry, I don't have much time. This is another, where the graph is the input actually. Your data is represented in the form of a graph, and that's going to handle in certain sense, like your neural network, convolutional neural network. These are the parameters I have used for analyzing the blast furnace data. This is the data representations, and this is the graph we have generated from the human knowledge. We allowed to train it. It gives us like this. And finally, we got a good correlations with the silicon content in the blast furnace, which is a very important element when we produce the iron or the kind of. So with this, I would like to quickly summarize the things because we should respect the time first. So I'm not going to read all these things. You can see, and meanwhile, if you have any questions, I can take 1 or 2 questions. We should respect the schedule. We should respect the time. So many questions, I will take 1 or 2. Rest of the questions we can discuss during the lunch hour because next speaker is waiting and we should respect that schedule. Thanks. Please.
Sir, you have shown this modeling, but is it valid for any kind of composition, means whatever the carbon range?
I have shown 3 model.
Yeah.
Can you specify, you are talking about the microstructure one?
No, sir. I'm now I'm talking about only the chemical composition. If I am taking any low carbon steel,
right,
and it is a 12-phase microstructure,
right,
suppose,
right.
So is it valid or is it applicable for a 12-phase microstructure steel or for
multi-phase? We attempted, the effort is given to use the as many as different kinds of microstructures possible. We are trying to understand whether dual phase, it is a ferrite martensite. So whether we are able to understand which part is ferrite, which part is ferrite, which part is martensite in your microstructure at all. So it will work. If you have any sample microstructure, please visit us. We will try to test our model. Actually, we are now in the phase of going to the industry and looking at their microstructure and whether we will be able to tell them or not, in context of whether in view of Industry 4.0, can this model help us to digitize the quality control part? That's the whole idea. It is sponsored by AINRF, at that time ACRB, CRG project. So we are working in that.
Sir, another thing is that it is not...
Can we discuss during lunch?
Sure,
because
sure.
we should respect the things. So, okay, please. Please, quick.
I have a very general question.
So,
from the ductility point of view, which
right.
microstructure is better, tempered martensite or benite?
Sir, we are now far away from the just ductility. Now we look at the ductility and in context of automobile applications, we are in competition between the UTS and ductility. Right, so the latest cutting edge research is ongoing on quench and partisan steel, which is basically martensite and ferrite and benite combinations basically.
Okay, thank you.
Thank you.
Thank you very much, sir, Dr. Subhash Ganguly, sir,
for more questions we will discuss.
And very nice session. Thank you. So, before continuing to next section, Dr. Satish has some pre-scheduled and urgent assignments he would like to leave. Now I would like to request our Vice Chancellor, Honorable Vice Chancellor, sir, to kindly present a memento to Dr. Satish as a token of love of our gratitude for delivering the keynote address and for gracing the conference with his valuable presence. For fourth session, I invite Dr. Ashutosh Kumar. Dr. Ashutosh Kumar is Assistant Professor and Associate Head at IIT Bhilai, Department of Material Science and Metallurgical Engineering. He holds a PhD in Physics from IIT Patna and has postdoctoral experience at IIT Madras, Poland, and France. His research focus on thermoelectric materials, high entropy materials, and magnetic refrigeration. He has published more than 45 papers and is a life member of YMRSI and has received several awards, including the outstanding paper in 2025 from Journal of Materio Miss. Now, I invite Dr. Ashutosh Kumar to give the presentation on the topic Novel Strategies to Develop Efficient Thermoelectric Materials for Power Generation Applications. Over to you, sir.
Very good afternoon to all of you. I'm very thankful to Vice Chancellor of this university, Dr. Adi Patidasar, Dr. Mahesh, Dr. Kalyan Fani, to giving me this opportunity to talk about different area than what you might be expecting. Can you get this pointer, please? Yeah, thank you. So in this talk, I'm going to present novel strategy to develop efficient thermoelectric materials that can be used for power generation applications. In the morning, we have listened to executive director regarding the power consumption and where we are lying currently and what is the next focus of the country. So we are basically moving towards the renewable energy where we are targeting to somehow harvest waste heat or any kind of waste back into some power or some useful applications. So this particular talk is focused on developing new materials where those materials can be used to harvest waste heat back into electrical power. So these are the content of my talk. I'll be very briefly talking about the fundamentals of thermoelectrics. Then the novel strategy which we have adopted to develop efficient thermoelectric materials. We'll discuss some case studies and conclude the talk. So first of all, we need to know what is this thermoelectric materials. So or what is this thermoelectricity mean? So thermoelectricity is a phenomena that can be where a direct conversion of waste heat back into electrical power is possible. Also, you can use those waste heat to generate power as well as for cooling applications. So it works in two different modes, either in power generation mode and in cooling application. The first part talks about the power generation, where you can see we have P and N type materials, where you allow, let's say on the top there is a hot surface. So let's say your rotary kiln where you have temperature of surface is very high. And what you can do is you can use that heat to move the carriers in the system. So this is a kind of module which is commercially available now, where that consists of P and N type of materials, where you can see, if you see how the power generation takes place using waste heat. So the first part is where you see we have some hot surface. We have two P and N type materials. So these materials are having majority carriers as electrons and holes in N and P respectively. So let's say you have N type of material where you are getting heat energy from this source. So the charge carriers in N type try to move from top to bottom, and charge carriers in the P type also move from top to bottom. Now, if electrons are moving from top to bottom, the current flow will be from the bottom to top, right? And the current flow is in the same direction of the holes. This way, when you are heating one end, you have flow of current in the material, meaning you can actually harvest this waste heat and generate power. On the other hand, the same setup can be used for cooling applications, where you can use the waste heat, or you can use this kind of modules to generate or to cool any particular device. And this can be used for storing medicines, some portable refrigeration devices. Why we need this? Why at all we need thermoelectrics? So as you can see, we are relying on different fossil fuels to generate different kind of energies. And when you are using those energies for practical application, you are losing a major chunk of it into environment as a waste heat. Around 65 to 70% of the energies which we are generating by other mean goes into environment as a waste heat. And it is a very high time to harvest this waste heat back into electrical power. And thermoelectric materials can do that. When you develop a material, you have certain parameters that you need to optimize. Then it is called a efficient thermoelectric material. So the utility of any thermoelectric material is quantified using a dimensionless quantity known as figure of merit, which we call as GT. And GT depends on S squared sigma kappa T, where S is known as Seebeck coefficient. Seebeck coefficient is basically a ratio. When you are applying a temperature gradient to a material, let's say you have a delta T. Due to that delta T, there is a gradient in the charge carriers that lead to a generation of voltage. So the ratio of voltage generated to the temperature gradient applied is known as Seebeck coefficient. And this electrical conductivity is the ability of a material to conduct electricity. And thermal conductivity is the ability of a material to conduct thermal heat. This has two components. The thermal conductivity consists of two parts. One is electronic part, other is phononic part. So materials that are good conductors of heat are also good conductors of electricity. So if the heat generation is coming from electron or the charge carriers, it is called electronic thermal conductivity. And any material has some crystallinity that leads to some kind of atomic vibrations that also conducts heat. That kind of thermal conductivity is called phonon or lattice thermal conductivity. Now, as you can see in this equation, this GT is a parameter that tells you whether a material is good or not. So in order to have this high value of GT, you need to have high value of Seebeck coefficient, high value of electrical conductivity, and at the same time, low value of thermal conductivity. This is very simple, straightforward, that like we need to have this kind of parameters. But the problem arises, the high value of Seebeck coefficient is achieved in semiconductors. High value of electrical conductivity is achieved in metals. High value of lower value of thermal conductivity is achieved in insulators. And you cannot make a material that can act like metal, insulator, and semiconductor at a time, right? So what we do, because they are correlated. The Seebeck coefficient, like let's say, if you know carrier concentration, so Seebeck coefficient decreases with the increase in carrier concentration. Electrical increases with the increase in carrier concentration, and electronic part of thermal conductivity is proportional to electrical conductivity. So we have a correlation between these parameters, and that restricts if you want to modify a particular material to achieve a particular GT, these interrelations between the thermoelectric parameters restrict that number, right? So there must be some approach that decouples, basically this is the decoupling of electron and phonon transport that is needed to achieve a high value of GT. Not only that, in this, the numerator of this equation, this GT, which is square sigma, is known as power factor and thermal conductivity. So you can see this S and sigma are directly related, so you have to optimize this S square sigma together. At the same time, you have to also reduce the phonon thermal conductivity. So there are two ways by which you can generate a material with better GT value. One way is the power factor enhancement, other way is the reduction in the thermal conductivity. And there are several approaches, conventional approaches that people are using to develop good thermoelectric materials. But in order to use them for practical applications, I mean, let's say in steel industry, we are working on a project where we are using these thermoelectric materials to make thermoelectric generators and harvesting this waste heat and generating power of currently it is a very small project of 1.2 kilowatt power capacity. So what we are doing is we are using this kind of materials to make the generator and then using those generator to extract the power. So in order to use the material for practical application, you need to have a material that has a good value of GT across a wide temperature range. And that wide temperature range is needed because efficiency depends on the value of GT across a wide temperature range. Now most of the materials, if you see, depending on temperature, if you raise the temperature, due to the correlations between these parameters, their value changes, right? So in order to have a better value of GT, we adopt two, in this talk, I will be focusing on two different novel strategies where we are trying to improve the value of GT over basically average value of GT. One of them is called AES-MPS concept, which is attuned electronic structure mismatch phonon structure. Another is entropy engineering. What is this AES-MPS concept? We use material having GT value in maximum value of GT in two different temperature range, and we make composite of it. What we do is we are first choosing materials that has GT value in two different regions, and then we try to attune the electronic transport such that the electron carriers or the charge carriers that are flowing in a material across a wide temperature does not reduce with increasing temperature. At the same time, we should have a mismatch in phonon structure. Means at the boundary, we want to restrict the number of phonons that carries the phonon thermal conductivity. So because we need a lower value of thermal conductivity, we need to restrict the phonon thermal conductivity. But at the same time, we need to have a high value of power factor. So we need to give a path for electrons at the interface. So this concept where we are proposing this is basically the optimization of Fermi level, where we change the Fermi level position by appropriate doping, and then matching them such that if you are making a composite, their electronic structure does not degrade in the composite. For this, I just added I'll show a first case study, which we adopted with PBT and USB3 system. PBT has a GT value, a maximum GT value. USB3 also have a maximum GT value. We made a composite. And first and foremost important thing what we do as a material scientist is we first check their stability. We see whether the phase which we have formed is in pure form or not. So for that purpose, we did X-ray diffraction measurement, and we found that the X-ray diffraction peaks corresponding to these two phases exist in the composite, and no additional peaks were found. That confirms that the material what we have prepared is in single phase. But that was not enough. We need to know whether any kind of diffusion is happening at the interface or not. For that purpose, we did scanning electron microscopy, both on the surface and on the crack by breaking the pellets. So you can see the uniformity of this PBT and USB3 phases are seen in the composites. Especially we made a layered sample where USB3 is on one side and PBT on the other side, and we found that at the interface, the diffusion between these elements that is present in the composite is very narrow. It's close to 1 micrometer, whereas the particle size which we have used for making this kind of materials was 15 micrometers. So that tells you that there's no diffusion happening at the interface. So, and the same is confirmed through elemental mapping and elemental mapping. Further, we try to understand the electronic and thermal properties in the composites. What we found is the electronic transport does not improve in this composite, whereas the phonon thermal conductivity also increases monotonically as we are increasing the concentration of the second phase in the composite. However, with this study, we concluded that there are two important parameters that we need to optimize in order to get an efficient value of figure of merit. So one was the particle size that we are adding, and the second was the Fermi level between the two, the difference in the Fermi level between the two compounds. With this learning, I'll skip this. With this learning, we have studied one more system, which is GET-WC composite. So first we modified GET with appropriate doping of manganese and antimony. As I told you that we have three parameters that needs to be optimized. So we needed to optimize the Seebeck coefficient, electrical conductivity and thermal conductivity. So for that purpose, we did Mn and Sb doping, where we improved the figure of merit for GET system by doing Mn and Sb doping. I'll skip that part. I'll just show the numbers, because the numbers what we got for a GET system was close to 1.6, which is 2 minutes. And then by optimizing the first part, we added one more composite, one more additives, which is tungsten carbide, which is a good conductor. And in this case, we could show the concept of AES MPS, where we found that the electronic transport is maintained and phonon transport at the interface is minimized. That lead to a figure of merit close to 1.94, with an average figure of merit is 1.09, and it leads to a efficiency of 13%. We also use the same material for making modules, because the purpose is to generate power using the waste heat. We have used the similar material what we have developed in the lab to make the module, and in the module, before making the module, we need to do some parameter optimization to check whether the material is suitable for making module or not. This is done using COMSOL multiphysics, where we make the module and then we see how potential, power and efficiency changes with current and temperature. This is one real module which we have prepared using the developed material in the lab, which gives efficiency close to 12%, which is one of the highest value of figure of merit in this kind of system for a particular range. Very quickly, the second part which we are adopting to improve or to develop efficient thermoelectric materials is entropy engineering. Most of you know this formula, Gibbs free energy, that tells you about the stability of a material, right? So we know, like, when this delta SH, which is the enthalpy of mixing, is 0 or negative, it is well and good, you can make solid solutions. But the problem arises when the change in enthalpy becomes positive, and it is not, this T delta S term is not good enough or high enough to compensate that positive change. In that case, you can use a concept of configuration entropy, where even if you have delta S mixing positive, you can have delta S mixing higher such that as you increase the temperature and the material having high configuration entropy, your thermodynamical stability, that is the Gibbs free energy, is actually dominated by this high configuration entropy. And then you can make, at times you are unable to make materials because of positive change in enthalpy, but using this concept you can make new materials where the thermodynamic stability is dominated by configuration entropy. We have adopted this. This was, high entropy concept was first demonstrated in 2004 by Cantor. But later in ionic bonded compounds, it was first demonstrated by Roast in 2015 in rock salt oxide. The same thing we have adopted to generate or develop efficient thermolytic materials, where the first study what we have done is based on lanthanum cobaltate. We are using this high entropy concept. We have shown a significant improvement in figure of merit at room temperature, and please note it is for oxide materials. It is one of the highest value of figure of merit for oxide thermolytics at room temperature. And so these are the strategies by which you can actually develop efficient thermolytic materials that can be used for power generation applications, where you can harvest waste heat in several industries back into electrical power. Thank you so much, and if you have any questions, please. I'm so sorry, it has to be very fast. Yeah.
So first of all, thank you for raising my awareness once again, awakening my awareness, I should say, regarding thermoelectric generators. It was a long lost topic. After my undergraduation, I almost lost interest in this.
Okay.
Because since the magnitude of generation is quite small. I would like to know, sir, the generator, what you said about 1.5 kilowatt.
1.2, yeah.
1.2 kilowatt. I would like to know the physical dimensions and physical specification, like its heat transfer area, power generation.
See, this physical dimension depends on the power of the module that you are using. If you are using for a wider temperature range, you can have this 40 mm by 40 mm module that can generate you around 18 watt of power.
40 mm by 40 mm for 18 watts.
40 mm by 40 mm for 18 watts. Okay. So let's say you are using a material that can sustain for further large temperature gradient, you can still increase the power within the same dimension. It is depending on the efficiency of a material that you are using for making the modules that can reduce the dimensions as well as efficiency also. That's what we are working on to developing.
So for your 1.2 kilowatt generator, what was the dimensions? What size it was, the heat source?
Right now what we are doing is, it is in some company in Raipur where we are using a rotary kiln. So the dimension is close to 40 meter by 9, 12 meter of diameter circumference. So we are just using one patch of it. Maybe it's close to half a meter in the circumference. We are using for 1.2 kilowatt power.
Okay, so can we expect it in future to be in megawatts? Should we
right
have
now
hopes?
it is in kilowatts.
Yes, okay.
For sure, because the only problem right now we are facing is the cost. We can make, and the availability of this kind of materials that is being used in these modules. Like tellurium, it's not easily available in bulk form. Sun is not giving us very large amount of these elements.
And one more question, sir, just last question. What is the minimum delta T for these generators to become economically viable?
Delta T has to be as large as possible, because that is directly related to the efficiency. But even if you have few delta K, you can use it for some other applications. Like some of our study is based on flexible thermoelectrics. Like you can use your human skin, your human body temperature to generate power, for which you don't need very high delta T. You just need few Kelvin, or maybe some like 0.5 or 1 Kelvin of temperature gradient, because your body is not very hot comparing to the atmosphere where you are living in. So even if you have very small delta T, that also you can use in some purposes. Even if you have a very wide delta T, you can use in some other purposes.
Okay, thank you. Thanks a lot.
Okay, thank you so much again, once again, for inviting me.
Thank you, Dr. Ashutosh, for the highly informative and insightful session on thermoelectric material. We are truly grateful for your valuable contribution, sir. Now we move to the next session, which is second last session. I am pleased to invite Dr. Niranjan Kumar. Dr. Niranjan Kumar is a professor of electrical engineering at NIT Jamshedpur with over 30 years of academic and professional experience. He holds a PhD from IIT Roorkee and specialization in power system economics, network pricing, electricity market, deregulation, electric vehicle, and renewable energy. He published more than 150 research papers, 8 book chapters, several patents, and guided 10 PhD, 40 MTechs, and more than 150 BTech students. Dr. Niranjan holds key administrative role includes Dean, Head of Department, and Chairman of multiple committees, and he is a senior member of IEEE. He has also represented NIT Jamshedpur globally, namely USA, Canada, Italy, and China. So now I invite Dr. Niranjan Kumar to give the presentation on the topic transmission pricing reform in India in a deregulated environment. Over to you, sir.
Good afternoon to all of you. As you are aware that this conference is very much related to metallurgical engineering, and it is very difficult to move any engineering without electrical engineering. So I have chosen a very small topic of electrical engineering, which is not so much technical to the electrical. It is related to electrical as well as financial and managerial, so that anybody can understand this topic, this discussion. First of all, I would like to thank the team of Professor R.D. Patidar, the Vice Chancellor of OP.jindal University, and Professor Kalyan, and all the members of his team. Now I would like to start the topic transmission pricing reform in a deregulated environment in India. You are aware with this. First of all, I will present what is the power plant and a little small history of the power plant I would like to present here. And then we will go to what is the need of the transmission pricing in Indian scenario. And then what are the methodology that is being adopted for the transmission pricing mechanism, and what is the present status of the transmission pricing. Because everybody is simply related to what is the cost of the power per unit. Everybody can say the cost of the power per unit, it is ₹4, ₹5, ₹6, something like this. But they are not so much aware that what are the components of the per unit of power. So you know that the first of the power plant that was of 130 kilowatt of the hydropower plant that was started in Darjeeling in the West Bengal in 1897. And then you come to the 1910, an act was passed in the parliament. As per this act, we have to take the safety measure of the electricity, and then move to the 1947. Every state was having the state electricity board, which will be responsible for generation of the power, transmission of the power, and distribution of the power. All the three organs were within the control of the state electricity boards. And the overall power means it is in the concurrent list. Concurrent list meaning it is within the control of the central government as well as the state government. In 1956, it was treated as the industry. And you are aware that the India is a very big country, and so it was very difficult to control the power flow of power in the country. So the country was demarcated into 5 regions: northern region, eastern region, western region, northeastern region, and the southern region. It was the concept in 1960. And since it was the responsibility of the state electricity board to generate the power, to transmit the power, to distribute the power. So there was the huge gap between the supply and the demand, and the electricity was not capable of giving the fulfillment of the demand. Then the government of India thought that why not some of the power plants should be installed in India, like the NTPC, NHPC, and the NIPCO, so that it should be responsible for the generation of the power. But after generating the power, there was not so much sufficient to fulfill the gap between the supply and the demand. The government thought that why not the FDI should be invited to come to India and install the power plant that came in 89 or 90. So there was the foreign direct investment for the generation of the power. And if you are not thinking about the transmission of the power, what about the transmission? We are thinking about the generation of the power. You are aware that the Power Grid Corporation of India came into existence in 1989. The responsibility of the Power Grid Corporation of India was to transmit the power in all the 5 regions and having the 5 head office in the different regions. So now we come to already the installed capacity presently, and at the time of independence it was 132 megawatt, and presently it is 467 gigawatt. So there is the huge development, so there is the huge increment of the power generation at the time of independence to that of the present time. To generate the power is not so sufficient. To transmit the power is very important. So the different, and these are the power scenario of the Indian power system at the present situation. Different data are given here. And these are the development of the regions. As you told that in 1960 there was the concept of the different regions in 1960. In 1992 the eastern region were connected to the northeastern region, because in some of the regions are having the ample amount of the thermal power, in some of the regions are having the hydro power. So it is very essential to transmit the power from one region to the another region, and the connecting regions are called the connecting link between the 2 regions are called the inter-regional links. So this is the development of the different regions, and finally we are having the overall one national grid, which is the near about in 2013 or 14. So this is the energy resources map of the different regions. It is the hydro potential in the NER and the upper part of the NR having the hydro potential, coal reserves mainly in the ER and the WR, and this is the evolution of the transmission pricing. After the power grid coming into existence, the power grid told that there should be the share of the power grid in the total per unit of the charge. Although this charge is very small, it may be 32 paise, 35 paise, something like this. If you consider the megawatt and the gigawatt, the amount will be in millions and the billions. So it is very important to consider the transmission charges. So the work related to is the what is the development, how the transmission pricing came into existence. So we have worked on this. IIT Mumbai is having the consultancy of the Government of India for the development of the transmission pricing. Also IIT Kanpur is having the consultancy in this direction with the Government of India. My work is related to that. So this is the growth stage 1, stage 2, stage 3, and the stage 4. Up to 1991, it was clubbed with the generation system. And 1992 to 2002, 2 to 11, it was also clubbed, means having the, now this is the inter-regional link capacity. The different regions are connected by the links. This is the capacity so that the powers could be transmitted from one region to the another region. And basically we are having the 3 types of the transactions of the power. There is the agreement between the power plant and the utility. So this is the first one is the long-term open access, and this is the first one is the bulk power transmission agreement having 3 years to 25 years, and the long term it is the 1 year to the 3 years and the short term open access. These are the 3 types of the transactions. Next one, we have taken the example of the eastern region, and this is the central power pool and having the different states which are the beneficiaries of the power pool. The different beneficiaries are the DVC, the Odisha, West Bengal, Sikkim and Bihar and the Jharkhand. These are the states which are having the allocation of the power in a particular power plant. Allocation means suppose the total power generation in the power pool is 3,000, 4,000, 5,000 megawatt, then there will be the percentage allocation of the power to the different states from the power pool. And the collection that very time it was on the pro rata basis. And this is the IR link pricing methodology, which is the very old methodology. 1/3 of the power will be collected from the one region, 1/3 of the power will be collected by the other regions, and 1/3 of the, depending on the users, that is the beneficiaries of the importing region which have received the power as per the commitment. These are the very old method, and this is not in working this time. But we have collected the different methodology which was initially used. One thing I would like to tell you, previously the transmission pricing was finalized by the Government of India Ministry of Power. But in 1998, a separate body was working. It is the Central Electricity Regulatory Commission which came into existence in 1998, which was responsible for the transmission of the fixing the transmission of tariff and for the generation tariff. So that in order to make the distance between the government and the fixation of the transmission of tariff, a separate body was working, and it was the Central Electricity Regulatory Commission, and for the different states, it was the State Regulatory Commission. So we have taken some open access charges. Suppose we are considering the seller utility is the Cell Durgapur steel plant, and the collecting utility is Bhilai steel plant. So, and 20 megawatt of power is to be transmitted from the source to the destination, and the time period is for 30 days, and the time period is for 24 hours. So this is the methodology. This is the Durgapur steel plant, and different interfaces are, these are the connecting interfaces, that it will go to the DVC, then the transmission service charge and the system operating charge. Every load dispatch center will have its charge. So that the system operating charge will be collected by the DVC, and then it will go to the eastern region, and then it will go to the western region, then it will go to the Chhattisgarh State Electricity Board, and finally it will be delivered to the Bhilai steel plant. So there is the accumulation of the charges, means this is the pancaking of the charges. Different centers are collecting those charges. So this method is not so much efficient, not based upon the engineering, not based upon the science. So the research are going in this direction. A methodology should be developed so that it should be dependent on the amount of the power transacted and the length of the conductor. So this is the simulation results for the open access charges, the different interfaces that we have discussed in the previous slides. This is the total cost that has been collected, and these are the Electricity Act 2003 and the National Electricity Policy, and this is the tariff policy. National Electricity Policy 2003 brought the revolution in the reform of the power sector, which was passed in the Parliament on 10th of the June, and National Tariff Policy says that there should be the tariff in Indian system which will be dependent upon the distance and direction of the power. Which direction power is flow and what is the distance, means it should be the megawatt mile method. And the tariff policy, all these are. So that means up to the 2010, the previous methodology was working, and the Central Electricity Regulatory Commission formulated another means the methodology, which is the point of connection charges. It is based upon the amount of power transacted and the length of the transmission line, which is means the based upon the science, based upon the engineering, based upon the research. This work has been done by the IIT Mumbai, and Professor Soman is working in this direction. He has taken the consultancy of the point of connection charges. So these are the hybrid method, means up to 2020, even the POC charges was not sufficient, means it was not so much relevant for the calculation of the transmission of charges. The Central Electricity Regulatory Commission, with the help of the IIT Mumbai, brought another rules, that is that there should be the hybrid method, which will be more efficient than the previous method working between 2011 to 2020. So this is the combination of it has brought the average participation and the marginal participation, having the combination of both after the 2020. So this is the hybrid method is accepted, and it is suitable for the Indian system. So this is based upon the particular node is being considered and how much power is coming from where and how much power is going to the which direction, which lines is calculated by this average participation method. So this is that has been considered what is the direction of the power flow. And new methodology, it has some of the advantages that we have discussed here. Point of the connection charges, it is the how much it is calculated, this is the technical. And what is done in the MP method, this we have calculated with the help of the marginal pricing method. Cost of each line is allocated on the pro rata to the agents and according to the total participation in the line. And because this method is also having some drawbacks, and 100% of the charges are not calculated with the help of these POC methods. So 50% of the charges are calculated by the uniform method. So this method is also having certain scope for the improvement. So these are the countries which are having the POC charges. UK is there, Norway and Brazil are the country where this method is working. So this is we have taken what are the demerits of the old regime, and because it is having the pancaking effect, because different load dispatch centers are having its own charges, unnecessarily we have to pay, so it becomes very burden to the customer. So all the previous methods have been removed and the new methods have been taken. So these are the new pricing POC charges. These are the advantages. Already told you this is based upon the science, based upon the engineering, based upon the research, this method POC. And because we are considering a particular line, how much a particular line is carrying the power, and what is the length of the transmission line, we do the load flow study, and then we can calculate the cost of the transmission. So this is the distribution is fair in this method, and computation is done with the help of the program, with the help of the iteration. So this method is very much scientific. And this is the conclusion of the work. The new method is also having a scope of the reform. All the previous methods are having some of the many demerits, and all the previous methods should be removed. So this is the, in brief, my talk. If anybody has any questions related to this. What is the
percentage? What is the percentage of transmission cost?
Percentage of, you can say it is very small, that you can say 40 paise per unit, and this I have not calculated, but very, very much small. But when we are talking about the megawatt and the gigawatt, it will be very large. In percentage, we have not calculated, but it will be very much significant amount to be collected from the customer.
So it will vary with the load.
Yes. Any question? Thank you.
Thank you, Dr. Niranjan Kumar, for your informative and enlightening session on transmission pricing reform. Now, I move to the last session by Ms. Sami. Ms. Sami is an engineering manager at SLB in Coimbatore, leading a team of over 300 engineers in designing advanced process system and production facilities. With more than 15 years of global experience in the oil and gas industry, Ms. Sami combines deep technical expertise with empathetic and innovative leadership. Driven by a passion for sustainability, Ms. Sami believes in maximizing team potential to deliver responsible multidisciplinary solutions that support a resilient energy future. Now I invite Ms. Sami to give a presentation on the topic Innovating with Purpose, Building the Foundations of a Sustainable Tomorrow. Over to you, ma'am.
Thank you. Thank you, everyone. I am audible? Yeah, I guess so. Okay. So I'm going to make this short. I know we have an audience that is a bit tired and very focused, okay? So first of all, good afternoon, distinguished guests, fellow researchers, industry leaders, students, and faculty of Jindal University. It is a privilege to speak at this prestigious gathering focused on steel, power, and construction technologies. Today I'm going to talk about sustainability, specifically how our different industries and different companies can join together for a sustainable tomorrow. The Agenda of 2030 for the Sustainable Development adopted by the United Nations in 2015 created 17 sustainable development goals. The aim of these goals is peace and prosperity for the people and the planet, while tackling climate change and working to preserve the oceans and forests. In the following minutes, I will focus on climate change. Our SLB sustainability framework is focused and built in three main pillars: climate action, people, and nature. We believe these are the factors and the areas where we can make the biggest impact to our company, our customer, and our society. We have the different governance procedures that enable us to make the change, and we also empower local teams to do it. We do have the technology, the innovation, and created partnerships to support and accelerate our sustainability objectives. Today, we will focus on climate actions, and more specifically on our roadmap to net zero. The carbon budget curve shows the reduction on CO2 equivalent emissions required in the following century to limit our rising temperature to only 1.5 degrees as set in the Paris Agreement. The climate projection change shows that we will reach this budget in 5 years from now, meaning in 2030. then that means we must balance the emissions in the next decades with a sustained negative emission actions beyond 2050. Our SLB logo, it is based in the carbon budget curve. It is a reminder of the challenge ahead, and it puts sustainability and strategy at the center of our company, at the center of who we are. Many factors influence this balancing act we are now part of, and we have the collective responsibility to reduce our greenhouse emissions for the planet to thrive. For a more sustainable energy future, we must decarbonize quickly, with visible and incremental progress. But the question remains, how? I'm going to give you a glimpse how SLB is doing that may serve as inspirations for you and for the future and for the other industries. One second. First, we need to reduce our Scope 1 and Scope 2 emissions. And this start evaluating and understanding the data, collecting the data, where your emissions are coming from. In our case, the major emissions in our operations comes from the fuel, for the natural gas, and from the diesel that we use in our operations. This represents the 80% of our total Scope 1 and Scope 2 emissions. Starting by determining where this fuel is used in the operations and the locations is the very start point. With this kind of data, then we can focus on optimizing the processes. Subsequent actions can be improving the job design, improving the engineering, doing equipment upgrades, electrification, and opting for low carbon fuel alternatives. Data quality is fundamental for the progress tracking and for the improvement. What you cannot measure, you cannot control. We can also conduct energy audits, and those will help us to identify the anomalies in the processes and the anomalies in the consumption. Another option is to install a smart energy monitoring system that will automate the data collection. Second, we must accelerate the decarbonization by using technology that continuously improves the efficiency, reliability, and performance to our customers. Energy manufacturers are on the hook of expanding their portfolio to offer products and services that are built on rigorous technical methodologies to reduce and quantify emissions. Those portfolios must address all the greenhouse emission challenges spectrum. Third, we must scale up our new energy systems and adopt them. We are seeing more and more partnerships and technologies dedicated to low carbon, neutral carbon, and even carbon negative solutions for the energy systems of the future. Do you want to decarbonize? Map your inventory, set ambitious targets, track your progress, and feed back your results to the business. In this gathering, we are focusing on industries that are not only foundational for the economic development, but also emblematic to the human being. Steel, power, and construction form the backbone of the modern civilization, and their evolution will shape the future we build. But with this growth comes greater responsibility. We need to decarbonize, and we need to decarbonize the steel industry. This steel industry decarbonization has initiated a new wave of technology. Achieving these decarbonizations requires multiple technologies and different technologies to work together in order to find the most appropriate and sustainable solution. To define the right solutions, the steel producers must focus and consider several factors: the local demand, the steel application, the market, the technical feasibility, and ultimately their desire to decarbonize. Many companies are laying the foundation to decarbonize blast furnace metal operations, for instance. They are dividing this into 3 different phases. The first phase focuses on optimizing the material and the processes. This means controlling all the parameters in the blast furnace itself. They can utilize or reutilize materials that will reduce the CO2 emissions. The potential of this decarbonization of this single stage is significant. By optimizing the material and processes properly, we can reduce by half ton the CO2 emission per ton of steel produced. This leaves for the producers to deal and focus on the remaining 1.5 ton of CO2 emission per steel produced. In the second stage, the producers may optimize their technology. When it comes to blast furnace, the carbon capture seems to be the most suitable solution and the quickest today in the market. The only challenge with this is that an average of 6,000 tons per blast furnace per day has to be captured. This gives us to 3 billions of CO2 to be captured annually worldwide. Not all the locations has the geological conditions required to store the carbon. The carbon capture can also be transported. However, this is not the most economical solution. Rather, this can be expensive. The cost associated to the carbon storage and transportation make sometimes the carbon capture a difficult decision for the steel producers. Third, given that some locations are unable to economically store the CO2 underground, there is an additional need to utilize this CO2 capture. More and more, we are seeing projects and applications in the world that are testing the utilization of the CO2. For example, in polymers, in synthetic fibers, and in fuel, for example. This last step of the decarbonization of the steel depends heavily on the development of technology and the market to utilize the CO2 capture. There is no easy and single way to decarbonize the steel. The solution depends on each plant's different factors, of the different necessities, the location, the external condition, the energy sources, and the material availability. All these are constraints that the steel producers need to work on to define the right solution. In the midterm or immediate term, we see that the carbon capture and sequestration is the quickest option to reduce the blast furnace emissions. However, as a society, we need to build a better economic scenario to this to be applicable at a larger scale. In our portfolio of SLB, we have decarbonization solutions for different industries. As I said, the carbon capture, as mentioned before, is the more suitable for the blast furnace and DRI that utilizes natural gas for reduction. Hydrogen is another alternative. We have two alternatives: electrolyzed hydrogen and blue hydrogen. Hydrogen solution is more suitable for the latest stages of the steel production, which is the finishing and the production, because it requires less fuel. We have the opportunity also to replace the natural gas in low volumes in applications for steel that are high-value product steels. The natural gas in the DRI and in the blast mix can also be replaced by hydrogen. The energy storage has a limited application due to the high demand of electricity in the steel industry. However, for those specific applications where the electricity demand is low, this can also be an alternative. At SLB, we believe that technology is not just a tool, it is a responsibility. It is a responsibility to innovate with a purpose, to collaborate across industries, and to build the systems that are not only efficient, but enduring. SLB Capture leverage a modular product offering scalable solutions for carbon capture that this will meet diverse needs in various industry factors. In our portfolio of Just Catch, we have delivered equipment as a turnkey project, while in the Big Catch, we deliver as a process package and a key equipment. This modularity ensures the integration and optimization and empowers the industries to achieve the decarbonization objective with flexibility and precision. Our technologies have been tested across multiple and diverse fuel gas, from the industrial processes to ensure reliability, efficiency in a wide range of industry segments. As we stand in the crossroads of industrial transformation, our role is clear: to enable progress through smarter engineering, to support sustainable growth, and to empower the next generation of thinkers and builders. Let's continue to work together, academia, industry, and technology leaders, to engineer solutions that uplift the economy, protect our planet, and inspire innovation across different industries. Thank you very much. If you have any question? Yes.
You are not able to control.
Yes.
Yes?
Yes.
So how do you measure?
So
First question. Second question is, once you measure, how do you know whether it is correct or not? How do you verify it and justify it?
good question. I'm going to speak about in the eyes of SLB what we are doing. So first of all, we create a methodology to measure the carbon emissions. This starts with all of our equipment. We know what is the emissions that we have, either for any venting or for any flaring. So we have that. We also have developed some emissions tools or emissions calculations for those fugitive emissions in the different valves. Now, how do we ensure this is the assurance? We also have the calculation, for example, for the material that we procure, and we match with the suppliers as well for this case. For example, what is going to be the cost associated to produce certain equipment, and not only because of the steel produced, but also the transportation cost associated. And how do we ensure this is? We are having some robots, for example, that we are installing in our different facilities, in our plants, that they go and take the measurement, and then we go back and feed that into the lab, and we get the results. So we have an installing monitoring system.
Hello. So there are actually gold standard. There is Vera verified standards available. There is greenhouse gas protocol. There is a new technology which is coming in the next year. India is coming out with CCTS. So the calculation part, the measurement part, there are difference in these standards. So how do you ensure for India, if you are, I'm talking about India, whether you will go for Vera standard or gold standard or the CCTS? And how do you ensure that your calculation is aligned with CCTS?
Well, it depends. We have clients across the globe, right? And they have different standards across the globe. So whenever we test the calculation, and if we have any certain qualification, we either adjust it or we mention to the client. So that's the first step. And then again, for the measurement, we have a monitoring system installed in all our plants that can test, collect the samples and test it, and we measure it, and we can retrofit to the system. In any case, our continuous evolution and technology keeps growing, right? So we continue developing different tools to measure the emissions as well.
It will be aligned with CBM?
Sorry, say it again?
CBAM, cross-border accreditation medicine.
No, I didn't get the question, sorry.
This is Europe. Europe is coming up with CBAM, calculation of greenhouse gas.
Yes, correct.
So whether in line with that CBAM?
Yes, we have the calculations in line with that.
So India will be getting that CBAM or CCTS? How do you do it?
So we calculate the emissions as per equivalent emissions, either for whatever is the gas, right? And then we convert those emissions to CO2 equivalent emissions, and also we have methane emissions separately calculated. And it comes from every composition and whatever is an estimation of the venting or the gas that we will have in our processes.
Thank you.
Okay. Thank you very much.
We sincerely thank Ms. Sami for her insightful session on building a sustainable future through decarbonization. This topic is indeed the need of the today's age, especially in steel industry. Now, as a token of our gratitude and appreciation, we would like to present mementos to all our esteemed keynote speakers for their valuable contribution to this conference. I humbly request our Honorable Vice Chancellor, sir, to do the honors of presenting the mementos. Number one, may I first invite Dr. Majumdar to kindly accept the mementos, sir. ठीक है ना, सब लिख दिया. Now I invite Dr. Subhash Ganguly to kindly come forward and receive the mementos. Now I invite Dr. Ashutosh Kumar to receive the mementos. Now I invite Dr. Niranjan Kumar to receive the memento. Lastly, I invite Ms. Sami to kindly come forward and receive the memento. Finally, I invite Dr. Mithilesh Sau for vote of thanks.
Good afternoon to everyone present here. On behalf of the organizing committee of the 6th International Conference on Advances in Steel, Power and Construction Technology, it is my proud privilege to extend a heartfelt thanks at the conclusion of this plenary session 1. First and foremost, I extend our deepest gratitude to all our distinguished speakers for their enlightening and thought-provoking presentations. Dr. A. Majumdar, Director, School of Mines and Metallurgy, Kaji Nazrul University, for bridging the wisdom of Vedas to ESG and showing us scriptural pathways towards sustainability. Dr. Subhas Ganguly, Professor and Head, NIT Raipur, for highlighting the immense potential of steel informatics in addressing challenges of the steel industry. Dr. Ashutosh Kumar, from IIT Bhilai, for sharing novel strategies in developing thermoelectric materials for power generation. Dr. Niranjan Kumar, NIT Jamshedpur, for his insights on transmission pricing reform in India. Ms. Sami, SLB, Coimbatore, for her inspiring talk on innovating with purpose for a sustainable tomorrow. Dr. Satish Kumar from NIT Jamshedpur for his valuable contribution on mineral characterization and utilization. We are truly grateful for the depth of knowledge and vision each of you brought to this session. I also take this opportunity to thank our Honorable Vice Chancellor, Dr. R.D. Patidar, conveners, Dr. Fani and Dr. Nitya, the session moderator, Dr. Mahesh Bhivapurkar, for skillfully conducting the session and ensuring its smooth flow. Special thank is also due to my fellow in charge, Dr. Trinath Talapani, for his efforts in planning and coordinating this session. Finally, a big thank to all the delegates, faculty members, research scholars, and students for your active participation and keen interest, which made this plenary session highly engaging and successful. With this, we conclude plenary session 1. We now invite all of you to join for the lunch at the ground floor of this building and continue the discussion informally. Thank you, sir. So, sir, I request all the speakers to be here for a group photo.
Professor Senior Grade in the Department of Metallurgical Engineering, OP.JU. Welcome you all to the technical session of the sixth International Conference on the Advances in Steel Power and Construction Technology. For this session, the session chair will be Dr. Anurag Sharma, Assistant Professor in the Department of Civil Engineering, OP.JU. So without wasting the time, I would like to call the first presenter having PID 1176. Okay. Sorry, the presenter's name is Pradeep Kumar S. and Sammy CH. Please, sir.
Good afternoon again. We are going to present the paper Innovate Ground Improvement Techniques for Sakarya Gas Field Onshore Processing Facilities. This paper is based on an actual project that we have executed and delivered, SLB, and the civil and structural part of this project, which was the most challenging one, has been led and completed by Pradeep Kumar Charmugabel. It's not moving. Can you go to the next slide? Okay. This is not working. So we are going to give a quick overview of the project, the challenges, and also the how we resolve these challenges. Thank you. The client is Turkish Petroleum. The project is located in Turkey. The project is Sakarya Gas Field Development, and Sakarya Gas Field Development. We started the project in Q4 2021, and we end the project in 2023. The aim of this project was a gas processing facility for 350 million standard cubic feet per day with their associated utilities. The impact of this project for SLB is massive. We strengthened our market share in the area and our position in the segment in Turkey. We also have an impact in our revenue. This project represents more than $500 million revenue for Schlumberger. With these projects, once again, we demonstrated our availability to deliver on time with such a challenging scope. Our team enhanced the expertise and the quality assurance and enhanced the technical knowledge. For our customer, we bring a lot of benefits as well. We reduce the construction and maintenance cost. We did some soil improvement techniques which allow us to select the proper type of foundation to reduce the maintenance cost. We provided a reliable infrastructure, and ultimately, we enabled the client to achieve the ultimate goal, the agenda of the national production. They were able to produce in 2023 the first gas of the recent discovery of the gas field in Black Sea. In order to execute this project, we start early with an early engagement and a concept solution. This concept solution also includes the challenges for the soil. We created a cross-functional team which include geotechnical expert, geotechnical construction companies, geotechnical team, construction companies, pile contractors, and our experts and our external experts for the soil. We defined in the team the roles and responsibilities clearly. We established how the decision-making procedure is going to be and how we will manage the risks. We retrofit with our results the project so we have a continuous improvement. Our team was located at site, not only the construction team, but also the engineers, the designers, and the experts. We celebrate each milestone achieved, and finally and ultimately we are sharing the knowledge of our experience. The site itself was the biggest from all the challenges of this project. The plant has to be located in a riverbed, which was a previous reclaimed land. This is a high seismic zone and has a liquefaction effect. This has an uncontrolled heterogeneous field and has a high settlement sensitivity. Also, we need to address all the climate conditions. In this region, we have the full spectrum from snow, rain, and summer. And also, we have constraints on the equipment, capabilities, and capacities for the depth of the drilling that they can reach. Not all the construction companies in the regions has this technology as required for this project. In order to solve all these challenges, we needed to introduce innovative techniques to solve this project.
Thank you, Samay, for sharing the floor. So good afternoon once again to everybody. So it's a post-lunch. I hope this will not get bored because it's a practical condition wherein we encounter the soil is a problem, and also we have challenges in a short milestone. So here we have adopted a concurrent approach, which is the innovative techniques that we adopted for soil improvement techniques, and what type of foundation that we have chosen for. And mainly this soil improvement, can you open this? So here the soil improvement, so it's mainly to accelerate the consolidation and reduce post-settlement. So that is the main challenge that we have observed here. And we have used the vertical drains, which are drainage columns that we have adopted for this particular innovation. And other one is the preloading, which is mainly to accelerate the consolidation and by the way improve the soil improvement. And apart from that, what is the type of foundation which you need to select for each type of structures? So that we have selected selectively. That we have adopted mainly the longboard piles, and other one is a Barrett foundation. Where the Barrett foundation we have a zero settlement that we can achieve with that foundation. But pile foundation, which will be medium weight of structures, that we have adopted here. So when we get from the site, so first the point is the soil factual report that we need to get it from the ground, and further to that a drainage column construction that we need to adapt. Based on the number of the spacing of the drainage column, etc., and the settlement sensitive structure to be identified, and based on that which type of foundation to be adopted. And from there, once we select the structure, we need to find the base pressure calculation, and from there the embankment and settlement monitoring that we need to collect from the data, and that we need to apply into the Plaxis 2D software, which will be giving the settlement means calculation. And further to that, whether the deep foundation construction will be get constructed. So one is a pile foundation, other one is a Barrett foundation. So this is how the drainage columns will be constructed in practical way. And moving forward, this is the plot area, and with the plot having a different blocks, and one block which is highlighted cyan color and green color, where the facility will be located, and which is mainly a gas facility. So the block 1 and the cyan color and the green color, where the hot strata will be available in the green color location, and in the cyan color having the loose soil, we do not have the hot strata. So in this condition, wherever the heavy loaded structures that we have located into the green color area, where the hot strata is there, and with the loose soil condition, the light loaded structure has been built. So this is how the gas facility has been planned. And this is the geological profile, where we get the borehole locations for the complete facility. And with this is the profile of the geological conditions, where you can find the fill material, and further to that silty clay. And again, if you go down for at a depth of 40 meter, even the soil condition is perfectly clay condition, so which is not suitable for the directly keep the foundation on the ground. So for that reason, we need to adopt the soil improvement. So this is the type of soil. It is a completely alluvium soil, and this is the borehole data you can see. So completely silty, and it's a limestone material. And this is the settlement calculation that we have using consolidation theory. So we have adopted this particular calculation, and we found that with the existing soil fill, using this calculation, we arrive that this will be having a own settlement with a duration of some years, So it is coming around 99 centimeter, which is closely to 1 meter, right? And which needs the settlement. For any type of structure, the settlement to be limited to 25 mm, that will be for the rat foundations, and for the remaining foundations, that will be based on the criticality of the facility, that we need to reduce the settlement value. So that to be restricted maximum by 5 centimeter, from 1 meter to 5 centimeter. So this is the challenge which we have in this site. And to do the soil improvement selection and design, so what is the spacing that need to be do the soil improvement, which is vertical drain, what is the spacing to be adopted? For that, we need to have two methods to be analyzed. One is analytical, another is a numerical method. Analytical by using this formula, and another one is the numerical method, which is a Plaxis 2D software that we have adopted here, and where we have to feed the data of the duration of the structure, and how many means the embankment construction, the foundation construction, the building of the structure, and then so keep on that 1 year period of time, so how much finally we are overloading on the ground. So based on that, that we have feed into the software, and we can get the value of the settlement. And for finally, by using this analytical and numerical method, so the value is closer in the range of the diameter of 0.8 meter is the vertical drain column size, and the spacing will be 5.65 meter. So it's roughly 5 to 6 meter the range. The same, the numerical result, the consolidation value, which is closely to 96.8% and 100%, and in the software which gives the 89 to 99%. So which means these results are very much closer. So finally we have adopted for the complete ground, the drainage columns is 800 mm dia, and the depth of columns is varies from 40 to 45 meter. And the spacing of the column ranges from 3 meter to 6 meter. And the fill material will be just gravel material, where the 25 mm to 75 mm is the gravel size. So this is how when the natural flow of the water, when you apply on the structure, means the load on the top of the fill material, so without soil improvement, it will go up and down. When we do the drainage columns, the water will be getting to the horizontal, and finally it will be get out of from the ground. And this is the preloading analysis, which is in the Plaxis software, which is in the Plaxis software. So where you can see it's a whatever the inputs we have obtained from the ground, and that we have adopted there, and the embankment size, that also we have plotted in the Plaxis software, and from there we are getting the settlement values. And when we do the embankment, so this is how the embankment, the settlement reading will be taking place using this inclinometer, horizontal and magnetic settlement columns, settlement plates, and vibrating piezometer. So and then total pressure cell for stress readings. So this we have adopted there with the help of geotechnical team. And once we have done that, we have gone into the selection of the foundation. The selection of the foundation, which I mentioned, there will be pile foundation, barrette foundation. So these are the two foundation that we have adopted here. So which is a board cast in situ pile, and a CFA column, so which is a continuous flight augering column, and the other one is a deep soil mixing, where the light loader structures we just using the deep soil mixing. So with the cement slurry that we have mixing with the soil, just we apply adding the water, so it will be just mixing it, so that the complete ground will be get improved. So this is just for a very light loaded structure, where the base pressure is very minimum. So otherwise we will be going with only board pile and the barrette pile. And even for any small kind of pipe supports or any small supports that we have adopted with the just to improve the soil by excavating the soil, and where we have used the boulders, and we have improved the soil locally. So I am just going over with the video how it looks ground from past 10 years data from the Google Earth. Actually, the complete ground was, it's a heterogeneous fill material. From 2010 onwards, the river was flowing on the facility, and then by 2016 still the river is flowing. After that they will be cutting the hill and they were making the ground very good. So from the river ground into the facility, so that was a big challenge. This facility has been built within a short span of 1.5 years. So first the improvement of the soil, after that with the foundation selection, and then the facility has been built. Now this complete facility is in operation, and there is no settlement issues, and even the particular site having a earthquake also have in Turkey in 2 times. There will not be any issue so far. Sorry. And finally, for the sustainability impact, okay. So because we are not disturbing the ground, we are just improving the soil. So by the way, we will be stopping the excavation. So because of that, we will be minimizing the environmental footprint by 9,500 tons of CO2, and then reduce the excavation material. So we have and the material use. So we are just drilling of means adding the material onto the ground, and further to that board pile and only the cost of the pile construction and the barrette foundation construction. And this will have a long-term operational efficiency, as I mentioned. So this facility is running successfully, and there is no issue in any settlement problem. And finally it's contribute to the climate goals. And this is the, and here are the pictures where in 2021 this was the site condition, and later in 2021 the ground having yes, the first slide mentioned by Samay. So this will be having a snowfall, and the facility in 2023. So finally this in good operation condition for SLB. So thank you, and question and answer for anything if you have.
The forum is open for the question and answer session. Yes, please.
Please back here. This one?
13, this one.
On 3, 13.
Yeah.
Maybe previous?
Previous one?
That table? Yeah, this one.
Yeah.
I can see in only 365 days, you are reaching 100% of consolidation,
yeah.
Right?
Yeah, right.
How?
Yeah, actually 365 days, the starting with the, first we need to understand the base pressure of the particular ground, and then we will be, okay, just a moment.
Actually, full consolidation means, you know, it takes lot of times, lot. Then even it do not reach 100%, but you are directly writing 100% reach.
Yeah, because we are applying the preloading, right? So actually to accelerate the consolidation process, we are going to apply the embankment. which means whatever the load which is required for the structure, for example, one building it is there, total value of the load that we have to.
There is another thing, but you understood my point, why it should not be 100%.
Sorry?
Why it should not be 100%? I think something wrong.
No, 100.
Because 100%, you know, it takes.
Yeah, it takes long
thousands of years. Even after that, it do not become 100%.
Yeah, 100%.
This is the consideration.
Yeah, okay, that's the second value you are talking about, right? In the analytical 100% you are talking about.
Whatever you say.
But if in the numerical side, if you can see 89 and 99%.
It's okay. It's okay, no problem. But 100% is problematic.
Okay.
In calculation maybe. And you go to that previous slide, maybe 8 or something. You have
But
that animation.
This one?
No. Go previous, yes.
Because you are not looking.
Previous.
Previous or?
Previous means lesser number of slides, yes. Go. Yeah, then, this one.
Yeah.
Drain columns, this is also drain columns. So both are drain columns. So what is the difference between these two types of drain columns? You have seen? Yeah, both are drain columns. So where is the difference? Some difference is there. One is for fine grain, another is for coarse grain, like that.
No, both are same. Because see, if the gravel will be filled on the ground, then it will be compressed, so slowly coming up.
I think that is for fine grain soil, fine grain, aggregate, and that is for.
Just to show the glimpse of how the drainage column will be.
Okay. So that's all from my side. Thank you.
Sir, can we move on to slide number 5? Back. 5. Slide 5. Here, sir, this one, sir. Sir, can you throw some more details regarding the liquefaction effect? How you dealt with that?
Yeah, actually, this particular site is having a seismic condition. So based on the Turkish standard of seismic, so the liquefaction effect will be during the earthquake. So there will be internal movement of the soil. So which will be the water will be flowing out. So by utilizing this vertical drains, so this is also be contribution to that particular effect. So this will be getting improved.
And since we're talking about high seismic zone, are you went for any isolation, any base isolation or something?
For seismic conditions, actually, we have followed the Turkish standard of seismic code. That whatever the coder classes was specifying, that we have completely adapted into the structure. Finally, the kinematic data that we have taken into for the kinematic analysis for the foundation design, mainly for the pile foundations, that we have adopted here.
So you went for non-linear analysis also?
Yeah.
Okay.
Thank you. Any other questions?
So can we adopt the same methodology for the vertical cliffs to strain the vertical stability of vertical cliffs?
Vertical cliffs?
Yes, sir. Vertical sloping ground.
For the slope stability.
Yes.
Yeah, slope stability. Yes, with the help of first retaining wall, and then yes, of course, that we can adopt. But while doing the grinding of the soil, drilling of the soil and then filling of the soil, filling of the gravel back. So there will be disturbance, right? Already the slope will get disturbed, so which may not be suitable for that particular location. So this will be for the topographical ground which is having a flat, this will be good. But for the slope stability, that we have to follow with a different method of improvement.
So recently in northern part of India facing a lot of problems.
Yeah, landslides, right?
Landslides. So in that case we can contribute something.
Because this particular drain having a 45 meter of deep, so first we have to take out the soil, then we have to fill in the gravel, right? So if the slope is already, which is not stable, when you do the grounding again it will be getting disturbance. So
can you explain this third picture? I think that is a vertical.
Yeah, this is the machine. Actually, this is the drain column machine where the augering will be there. So it at a depth of 45 meters. This is the limitation which is available in that particular region. So this can drive at a depth of 40 meters, 40 to 45 meters is the max, and then the soil, the gravel will be filled. So this is also one of the challenge, because with the limitation of equipment and mainly for the drilling of the particularly for the soil improvement as well as the pile construction. So utilizing that particular equipment availability, we have gone with depth of 40 to 45 meter, even for the soil improvement as well as for the pile foundation.
Okay, thank you, sir.
Yeah. Thank you. Thanks for the opportunity. Thanks to OP.jindal team and thanks to Vice Chancellor of this OP.jindal and faculty members and research fellows for listening this, and thanks all the people participants. Thank you.
Thank you, everyone.
Thank you, sir and ma'am. Now I would like to call another presenter having PID 1176, who is going to present on breakthroughs in AI CNT CSA composite technology for enhanced power systems and industrial performance.
Good afternoon, everybody. Myself Manas Ranjan Bera, and I am an undergrad in my final year. And actually, today we So today we will be discussing about breakthroughs in aluminium, carbon nanotube, and CSA, which is coconut shell ash. So composite technology for enhanced power systems and industrial performance. So we'll start. So why aluminium, you may ask? Because it is already widely used in our industries, and because of its because it is lightweight and it is non-corrosive, so and we can actually make complex shapes out of aluminum, so it is why. But aluminum has its own limitations, like for high performance industries such as aerospace and defense, aluminum is not strong enough by itself. And for automotive components that face constant wear and tear, aluminum surface wears out too quickly. So researchers started reinforcing aluminum with additional materials, creating what we call MMC. MMC is like metal matrix components. Over the last few decades, many researchers have reinforced with ceramics like silicon carbide and alumina, synthetic carbon-based materials like graphene and carbon nanotubes, CNTs, and even natural waste products like rice husk and fly ash. So, but why we choose CNT and CSA? The reason behind choosing CNT and CSA is carbon nanotubes are fascinating nanomaterials. They are essentially rolled up sheets of graphene forming cylindrical tubes, just a few nanometers in diameter. They have extremely they are actually because of their tensile strength and good Young's modulus, around 1 terapascal, it is being used. And in other hand, coconut shell is widely available in our country, and it is low cost and it has high silica particles available. So we tried using a few CSA and CNT materials in our aluminum. So the research gap that we are having is dispersion issue in CNTs, which agglomerate into clusters, and CSA particles sometimes stick together, which makes them uneven distribution, reduces the performance of our aluminum composite. Synthesis of the component. We use various types of methods for synthesizing. Several methods like powder metallurgy, stir casting, spark plasma sintering, and all. So first, actually, powder metallurgy. It involves mixing aluminum powder with CNT and CSA, compacting them under pressure, and then sintering at high temperature. The advantages are very good control over composition and distribution, minimal unwanted chemical reactions because of relatively low temperature. Limitations are high energy mixing that can damage the CNT, and some porosity often remains after mixing and reducing the strength. So secondly is stir casting, and stir casting is most popular method which is used in large scale production, where the aluminum is melted and CSA particles are preheated and stirred in it, and CNTs are added. Often using of ultrasonic vibration and improved dispersion. Advantages: it is very cost effective and scalable for industry, and limitations are CNTs tend to float or clamp due to density mismatch. So the next is additive manufacturing, which is techniques like laser melting and friction stir processing, allowing the creation of complex shapes. Advantages are opens the door to 3D printing of advanced composite parts. The grain size structure evolution, as you can see, the grain size of a normal aluminum component is 50 to 100 nanometer, and if we add 1% of CNT and maybe 5%, I can't even actually 5% of CSA, we can get the grain size of 10 to 15 nanometer. So let's talk about the mechanical properties. Mechanical properties of a pure aluminum is somewhere around 100 ampere to 200 ampere, somewhere around 100 ampere, but if we improve that, it will go to 250 to 280 ampere. Okay, that's fine. So, okay, sir. So, any questions? These are the applications that where it will be used. Actually, high voltage wires here. Sorry, thank you, sir.
Did I disturb you?
No.
Just be here for a minute if anybody wants to ask any question. Any questions, please? We can take only 1 or 2 questions. If anybody is having, please raise your hand. Okay.
Hello. Where we get this CNT, carbon nanotubes?
Yes, sir.
Where we get?
Sir, actually we produce it from using CVB.
CBP. You are producing what? You have produced these carbon nanotubes.
Sir, I know only there are two types of single tube and multi.
Okay. Thank you.
So actually, thank you, sir.
Okay. What is the aim of your paper exactly? I didn't find
Sir, actually,
any experiments or.
Yeah, sir. The aim of the paper was to making the aluminium more durable and giving it more strength and making it more resistive to wear and tear.
So whatever percentage variations you have shown, like somewhere you have shown between 15-20%.
Yes, sir.
How you are proving it? Like,
actually,
I can't
sir,
find any graphs or something like.
Yes, sir. Actually, these are from our references that we have taken from books.
So this is a review paper.
Yes, sir. This is a review paper.
Okay.
Thank you, sir.
Okay. Thank you.
Next we have a presenter, Mr. Prakash Singh Bagga, MD, SMS Metals Private Limited. He is going to present on SRP, a novel refining process for acid-lined induction melted steels with PID 1138. Please, sir.
Hello, good evening, everybody. Thank you. I feel proud and I feel pleasure to be speaking to the audience who belongs to second and third generation before me. And I will be speaking for a very short time on a very new topic which we have developed ourselves, because I am connected with the process of steel making. So this process has been named as SRP, means simple refining technique process. Now, why this technique was developed? Because we see that we have two types of steel making processes at present. One is through the blast furnace route, and second we have electric steel making. Now in electric steel making also we have nowadays two types of processes, one using electric arc furnace and other using induction furnace. In fact, when induction furnace was introduced, it was never meant for making bulk of the steels. It was simply a melt and tap process. No change in the composition. You simply melt whatever is available and cast it. But it is very surprising that the contribution of induction furnace for bulk of the steel making, it has been developed by India itself. This is a contribution of India. So, with the changes in the market conditions, there was a very big limitation of induction furnace of refining of steel. And when the steel plants based on induction furnace were installed, they had never thought of that they would ever require to refine their steel. They never thought of it. But at present, with the BIS specifications, there has been put a limit on the impurities of steel for induction furnace producers also. So we thought of developing a short process where the induction furnace steel could be refined to the electric arc furnace steel level without installation of much costly equipments and within their setup, a process which could be established within their setup. So what we thought of doing is that the major problem is related with the removal of phosphorus. Sulfur removal is not a problem because they are using mostly sponge iron, and it has already very low sulfur. Now this phosphorus cannot be removed in the induction furnace because of certain limitations. One is the lining of the induction furnace is acidic, and in acidic lining present nothing can be refined. And then second, it is the shape of the vessel itself, because it is very depth and surface area is very little available. Then thirdly, no oxygen injection can be done in the furnace itself. So there is no possibility of removing any phosphorus in the furnace itself. But recently, the people have installed LRF for removing phosphorus. Even the induction furnace people have been advised to install LRF, which is an equipment which is used by electric arc furnace steel maker as a secondary equipment, not as for phosphorus removal, but for other purposes. So it has been found that the cost of removing phosphorus in LRF, it is very costly. Number one thing, LRF is not meant for removing phosphorus itself, by itself. It is possible to remove in the LRF just as it is removed in the arc furnace, but the rate of removal is very slow, it takes very long time, and the process is very costly. So we thought of developing a process where the phosphorus could be removed even without use of LRF and very quickly. So this was done in the ladle itself. So we developed a process where steel from the induction furnace could be tapped in a ladle, where by making use of an additive in the small quantity, because normally if you use phosphorus, you will say require X amount of agents to be added. So we did this in the ladle by using only 20% of that X amount which is required for the removal of phosphorus. So this helped in establishing the process, because if in the ladle you add any large amount of additives like lime, milliscale and oxygen, there is a temperature drop and the heat may go cold. But with just 20% of special additives, it was possible to bring down the phosphorus from 0.09 to 0.03 within 10 to 12 minutes. But again, any treatment done in the ladle, there is a drop in temperature. So this steel cannot be taken for casting directly. So now this needs to be superheated. So for superheated, we suggested that this metal can be done in two ways, superheating. Either you take this ladle steel to the same furnace for superheating, or you install another furnace where you can take the metal to that another furnace for superheating and alloying. So by taking second sequence, by making use of two furnaces, you can maintain your production as well as you can improve the quality of the steel as equivalent to the electric arc furnace. So basically SRP jo hai, it involves two induction furnaces. One is normally acid line, another superheating furnace which can be acid line or which can be lined with high alumina driving bars, where this second furnace can act as good as LRF, which is done normally used. So if we compare the cost of refining, the cost of refining in induction furnace is always going to be lower than the arc furnace, because there are no electrodes, there are no bricks, there are no power losses. So induction furnace is very efficient melting equipment, no doubt. So if we do both the processes in the induction furnace, you can produce the same quality of steel as which is required by the BISI specification. And this we have conducted very long trials, even in 20-ton induction furnace. And there was a plant in Durgapur known as East India Holding Company. They gave us the opportunity, and they are still using for the last 4 years this technique, and they are making alloy steels, not only mild steel. So recently, another plant in Durgapur, Balaji Steels is the name of the unit. They have used last month, full month they have made carbon steel with this technique. So they have been able to get phosphorus down from 0.09 to 0.03 consistently without any problem. So if we compare the cost of refining, through LRF if you do that, the cost is coming around 4 rupees a kg of removable phosphorus. Whereas with this process, if you take back to the furnace, same furnace, then the cost is around 3 rupees kg. But if you take a separate superheating furnace, then it is less than even 1500 rupees ton. So the process of this simple refining technique with superheating furnace, installation of superheating furnace, you can produce the steel most economically for meeting the BISI specification, and you can still refine the steel of acid induction melted furnace. So this was the, we have shown a process also. There is a figure, I tell you, very interesting figure. Now, again next figure, this figure, you can see we have shown. This is the melting furnace, this is the melting furnace, this is that setting in the ladle, then refining everything added. Then this ladle, heat from this ladle is taken to the top of the packing induction furnace. This. Now, by doing this so, you can avoid the slag off from the ladle itself. Because slag of taking from the ladle is again a very typical issue. In this case, you need not to do any slag off. When the metal comes from this ladle to the furnace, slag will remain in the ladle, it can be removed. And then here it can be superheated and alive, and then it can be taken to the casting ladle for control cast. So this process is very quick and very simple. That is why it has been named as SRP process. So this is all about this process. If you have any question, I will answer now for that. Thank you.
Thank you, sir. We can take 1 or 2 questions. If you have, please raise your hands.
Yes.
What is the SRP?
Pardon?
In your title, SRP.
Simple refining process.
Oh, it's written, huh? So you have you have a nice surname, Baga.
Yeah, yeah.
And in middle, S dot. What is that S?
Singh.
Okay, sir. Thank you. I missed it actually.
Thank you, sir, for such an wonderful presentation. I think more than me as a civil engineer, I think metallurgical people can have a better questions for this. So, Trinath sir, if you want to ask, or ma'am, because you belong to this field.
So we have already cleared our doubts
Okay.
before it's
Okay, sir.
Sir, I am asking one question
Yeah.
that it's for only for the acid-based type of, means what is the refractory status of this induction furnace?
Regarding its effective status regarding?
Regarding this SRP, what is the refractory architecture of this furnace?
No, it is very, very quick. Because within 10 to 12 minutes you can remove phosphorus in the ladle, which is not possible at all.
So is there any refractory limitations for such type of design?
No, simply a ladle, same ladle, it has to be lined with the high alumina instead of any acidic material. That's all.
Only acid medium.
Only high alumina ladle is required.
Okay.
That's all. And it is to be taken as a treated ladle, treatment ladle.
Okay.
Because for superheating you are taking to a second furnace, and then ladle, normal casting ladle you can take for casting.
Thank you.
Thank you, sir.
Okay, thank you very much. I am very much delighted to be here, and I can tell you that I met Mr. Trinath ji in Jamshedpur long back. So we have been in contact since then. So this time I thought of coming over here from to just see all of you. Thank you very much.
Thank you so much, sir. Now we have our next presenter, Dr. Arka Ghosh, with PIT 1150. He is going to present on the topic Synergistic Reinforcement of Aluminium with CNT, HPN Hybrids, Microstructure Agglomeration Control and Mechanical Performance. Please, sir.
Working
Hello. Hello. So very good afternoon to all of you. Myself, Dr. Orko Ghosh from CV Raman Global University. So right now I'm going to present on the particular topic, synergistic reinforcement of aluminum with the CNT is carbon nanotube, and the HBN is a hexagonal boron nitride. So these two particular reinforcement, how its impact on the aluminum to enhance the mechanical properties with respect to the refinement of the grain and their microstructure. So the contents I will going to one by one. These are my contents which I'm going to present. So why we go for the aluminum? So as previously one of our students had already described the why aluminum we choose. So aluminum actually a metal which are easily available in the market. Apart from that, it has a the density at 2.70 gram per cc, which is far less than of the steel. Second is the most commonly used element, then good electrical and thermal conductivity. But it has some drawbacks. The drawbacks actually store high temperature mechanical strength, which reduce the corrosion rate. So some of the aluminum or aluminum alloy actually we are using in the particular automobile parts. So that automobile parts have some of the drawbacks. So if the weight of the particular aluminum alloy will be high, then there will be some consumption of your petrol or any fuel. So that fuel actually increase the carbon dioxide emission. Now the people are so much concerned about the carbon emission and the reduced carbon footprint. So to overcome this type of situations, we are going to develop the aluminum like metal matrix composite with the reinforcement of 1D or 2D materials. So whatever the target, whatever we have proposed, is like engine block. So that particular engine block have some operating system and it will go some like pressure. So that type of aluminum alloy people are using, like that's a aluminum copper Mg, aluminum Mg Si. So these have the drawbacks are there. To overcome these drawbacks, we can propose some ceramic or carbon based reinforcement to 1D or 2D nanofillers, so which can enhance or maybe enhance the properties of the particular aluminum. So as we do the conventional composite, we have some drawbacks. So to overcome these drawbacks, that reinforcement is come to the place. So that reinforcement actually has a high strength of the modulus and good wear as well as the high thermal stability. So that reinforcement, if we incorporate the particular metal matrix, so that whatever the metal matrix we are getting, it's a hybrid nanocomposite, so that can overcome this type of problem. So some of the reviewers have that reviewed, lots of reviewers have worked on the particular CNT and the boron nitride, but actually that two synergistic effect of continuously like boron nitride and CNT has not been done yet. So these are the literature reviews. You can see that aluminum CNT, aluminum CNT, aluminum CNT, or either CNT or multi-weld CNT they are using, or either aluminum HBN has been used. So in the next slide you can see that these are the, in previous slide you can see the mono reinforcement, a single reinforcement has been used. In this slide you can see that binary reinforcement people are using, like these are the boron nitride microparticle, boron nitride nanoparticles. These are the monofiller of the HBN with aluminum alloy. There you can see the some amount of CNT with graphite nanoplatelet. These particular things are done by our seniors. These things, one we can give that 1 weight percent boron nitride, 0.5% of GNP. GNP actually graphite nanoplatelet. So from the whole the literature review, whatever I have presented and previously we have gone through, no one has been presented yet the synergistic effect of CNT as well as HBN, how it will impact on the particular metal matrix, whatever we are using the aluminum. So our main motto to research gap, the limited studies I already told the CNT HBN has not done yet. The agglomeration challenges as we using the nanotubes, so nanomaterials, so there will be lots of challenges to how to control the agglomeration, which will affect the properties of the mechanical as well, especially in the wear properties or tribological properties. The third thing is that in climate property evaluation, people have not done that much of nano level microstructure evaluation. Then the correlation between microstructure and mechanical property, how the microstructure will important part to enhance the particular mechanical properties. The third one, the application oriented knowledge gap. To overcome these are the gaps, so we have found some of the objectives. So the objective is to like development the aluminum CNT HBN reinforcement to the ultrasonic assisted by the conventional sintering followed by the powder metallurgy. The second one to how these nanoparticles enhance the grain refinement and the mechanical as well as the tribological property. The third one, you can see that the tribological property, how the wear performance has been increased with respect to the pure aluminum. And the fourth one, that overcome that thermal stability, whatever the wear properties, whatever in the pure aluminum has problems, so that problem we can overcome by this situation. So we have done, like these are the schematic of sonication we have done. So that sonication actually aluminum, CNT and HBN we have done the, like in acetone medium. And we have done first 2 hours sonication. After that we have dried that particular material in the normal dry oven for the 8 hours. Then whatever the material we are getting after solidified, then we have go for the uniaxial compaction, 550 MPa. Then we go for the conventional sintering, that it is the like 2 hours sintering and temperature 2 hours holding time. And the temperature we are getting 550 degrees centigrade for 2 hours in the argon atmosphere. So these are the schematic we have done, and whatever the samples we are getting, this type of samples we are getting from the powder metallurgy, it is a 10 mm diameter at 2 to 3 mm thickness. So now we have done the some like properties, like things are there. So we have done some raw material testing. So these are the raw material of pure aluminum. This is like CNT, and this is the boron nitride. So whatever boron nitride we have done, it is a 20-hour ball mill, because whatever boron nitride we have procured, it is like micron level. So we have done the 20-hour ball mill, so reduced to the nano level. So we have done some TM or some like optic, that this is the FEACM. So you can see that nanotubes are showing in the, it is a tube-like structure. It is some nano level structure, it is there. So this figure actually bulk HBN, then we have done the ball milling. So you can see the lateral width has been increased and thickness has been reduced. We have done some of the DSC TGA parts, so how the thermal stability will affect on the particular aluminum metal matrix. Then we have done some mixing of the particular boron nitride as well as the CNT, how it is mixing with each other. So you can see that that CNT actually agglomerate with the boron nitride at a particular weight percentage, and this aluminum, these are big particles of the aluminum, and in the center you can see that boron nitride and CNT has agglomerated with each other. So it will create much problem when we increase the loading level of the particular reinforcement. Then we have done the sintering process. Then these are the like XRD analysis of the pallet. Then you can see there is a pure aluminum, but they have a peak of Al2O3. But whenever we do the sintering, so the Al2O3 has been diminished. So there were no Al2O3 peak in the composite. Then we have done some of the porosity analysis, surface porosity through the optical microscope. We have seen that this is a pure aluminum, the porosity, surface porosity 1.30%. Whenever we incorporate the these two nanofillers, we can see the porosity has been decreased 0.79. This is 1 weight % of CNT and HBN reinforcement. Then this is 2 weight % HBN reinforcement. This is 5 weight % NV reinforcement. So you can see that whenever we increase the like particular composition of the your CNT HBN reinforcement, you can see at 5 weight % your surface porosity is suddenly increasing to like 0.71 to 15.6%. That means of that CNT play a major role to agglomerate that particular HBN, and which will cluster in the particular this in the voids, and it will create the pores, which will affect the mechanical properties of the particular composite. So these are some optical like grain size distribution we have done. So from there, this is the pure aluminum. So we can see that whenever we have given the 1 weight % like CNT 50 and boron nitride 50 reinforcement, so you can see the suddenly decreasing in the grain size. So that means that, sir, that means there have some synergistic effect or the pinning effect of the particular reinforcement, which can see in the 1 weight % reinforcement. So whatever the 1 to 5 reinforcement you can see, so it is lesser than the grain size is with compared to the pure aluminum. Then these are some ACM like micrographs with the elemental analysis. So you can see these are some pores. Whenever we increasing the weight % of CNT, the pores has been increasing and the voids has been so much. Clearly you can see the voids are there, and the proper microstructure we are not able to see whenever increasing the weight % of CNT and HBN. So it will affect the properties. So these are the HRTM analysis of the particular nanocomposite. Okay. So we have done some like wear properties. So wear property, you can see that this is the pure aluminum. So it is 2.11 the width of the your weight track. Whenever we incorporate of that particular reinforcement, we can see that that width of the decreases with respect to the aluminum. So from this, we can conclude that CNT and HBN has more important part to enhancement the property of the particular composite. And 100% show the better property with respect to all the reinforcement as well as the pure aluminum. Then CNT improve the stiffness of the load transfer, where the boron nitride enhance the wear resistance, as this is a 2D nanofillers, and it will create the type of film, the particular nanocomposite. And last, that optimized hybrid 100% is the optimum CNT 50 and HBN 50 reinforcement, which can overcome the situations which are creating in the monofiller. So acknowledgement. So I want to thank my supervisor, Professor Said Nasimul Alon, Associate Professor in IT Raulkela. With his guidance, I have done this project. I would like to CRF facility in IT Raulkela, and not the least, the C.V. Raman Global University and OP.jindal University to give me the opportunity to present my work in this beautiful forum. So thank you.
Thank you, sir. Now the forum is open for the question and answer round. Yes.
Can the composite aluminum materials can be recycled?
Yes, sir. It can be recycled, sir. Actually, sir, this is a powder metallurgy route. So we can break it by like a normal compression thing. So we can get the powder. So that powder, actually, we can again go for the compaction and again go for the remelting, sir.
This can be powdered?
Yeah, this can be powder, like powder metallurgy route. And there was some route as that
after sintering, strength increases very
high. Strength increases,
so
but
how
as
this can be powdered then easily?
So easy, like if you sudden compression level, if you press on the particular pallet, so it will become a powder, sir. It will like break, because it does not have that much of strength with compared to the casting. If you go for the stair casting or squeeze casting, so that much strength we don't have in the powder metallurgy route. So that powder metal, actually that have drawbacks. The complex shape we are not able to get, the strength we are not able to get with compared to the casting. So if you give some certain amount of pressure, like I'm giving the 20 kilonewton of pressure, if you get, so it will become easily in powder. So again, we can go like powder it, then again you compaction it, or then again you go for the sintering.
First of all, a very creative and very beautiful presentation.
Thank you, sir.
No doubt from me, just in slide 5.
Sir.
In what way we are going that lower Young's modulus, that is E stress upon strain, how it is getting lower?
So here, sir, in this particular, actually, sir, we are like, these are drawbacks we are getting. Like these are drawbacks from that different aluminum alloys. So to overcome these drawbacks, I propose these things.
Okay. That way.
That is the thing, sir.
Right. Thank you.
Okay, thank you.
Thank you, sir. Acha.
Thank you, sir. Very nice presentation. I am just asking that whatever the nano range you have attained.
Yes, sir.
So how do you get this through AFM, atomic force microanalysis?
Sir, in the nanotubes you are telling?
You have shown one.
Yeah, nanotubes are actually.
Next. I mean SEM.
Yeah.
SEM. Image. Here.
Sir, this is from FESEM.
FESEM.
Field emission microscopy. And this is from the HRTM, high resolution transmission microscopy. So from there we can justify this is a nano levels. And from there we can also justify this is MWCNT or SWCNT.
Okay, thank you. Got. Nice presentation.
So
Your thank you also very beautiful.
Yeah.
Last slide, thank you.
Yes, sir, thank you. Yeah.
If you want to make this in a application base, then you have to go for a large quantity.
Then you go for the casting route, we can go. So this is the like proposed our main motto from the powder metallurgy route. We have to go for the like that how much percentage will be the minimum percentage at that amount of CNT and HBN if we mixed without any agglomeration or without any mechanical property like detrimental. So that particular weight percentage we have to fixed. So that's why we are going for the powder metallurgy. If that process is good, then that particular weight percent and particular things we can go for the casting route. Like switch casting.
But during casting, the distribution of CNT will not be maintained.
Possible.
So you have to go for additive maybe.
Additive manufacturing.
That will be a industrial process.
Yes,
we can go. Sir, but if we add CNT and if we want the same distribution in liquid metallurgical route. Yes, that is large, but in terms of the composite, if we add CNT, then that will be a very tough job.
It will decarbonize. It will become vaporized.
Even though it is a nano size and the weight is very low.
Yeah.
So during casting, it will float.
So additive manufacturing will be the
that can be a better route. Okay. Otherwise, like good volume of work.
Yeah.
It is a nice study. Thank you.
Thank you. Okay. Thank you. Thank you.
Thank you, sir. I have a request to the participants that please be restricted to the 5 minutes of your presentations and 2 minutes will be for the question and answer round. So next presenter is Mr. Zamarul Sheikh with PID 1160. He is going to present on the topic Impact of Recycled Concrete Aggregate on Mechanical Characteristics of Natural Virgin Aggregate. Please, sir.
What I would say in 5 minutes. Hello, am I audible? So, good evening to all of you. Where is my slide? Okay. I can't see actually. So, I am here to give a proxy presentation actually in place of my student Kaushik Kumar and Sital Mahapatra. I came to present. No issue, I have a health issue. I have problem in speaking. So, please cooperate with me. So, I am here to present the paper on impact of RCA on mechanical characteristics of natural virgin aggregate. You know, recycled concrete aggregate means that aggregate which we got from demolition waste. Okay, you know nothing lasts forever. Everything has its life. So, since last few decades, we have constructed lot of buildings. So, after their expiry, where the demolition waste will go? So, regarding that, our students have taken an effort to do something, and they are very in initial stage, just they are doing some basic characterization. Out of that, we have written a paper and tried to communicate, and thank you for your acceptance. So, let's go, please. So, just I will read out. So, as you can see, I told already what is the necessity of our research and motivation. And lot of people are working on this area. Lot of things has been done by a lot of researchers. So, you might feel like it's kind of repetition research, but maybe. But we are searching for some novelty. Still, we are in literature review. So, let's go. So, based on our research background, we fixed our goal, objective. So, this study aims to evaluate RCA properties through laboratory test, like including test for specific gravity, test for average impact value, crushing value, abrasion value, and also water absorption capacity. So, you can see in our nearby site or maybe inside the campus, some construction demolition waste we have collected, and that is the pictorial diagram of that procedure, collection procedure. So, then we have started our research. So, what we did? Actually we added some amount of percentage of RCA to the virgin aggregate. Then we do some test for that mixture, okay, and then we got some value some property value, parameter value. So to assess the effect of RCA substitution on these essential features, comparison means virgin aggregate, RCA aggregate and mix. So we will compare. So let's go. As you can see in here, that side, what is this? Percentage? Oh, sorry, specific gravity. So when we are adding RCA with the virgin aggregate, you can see the specific gravity is falling. Why? Because we are adding some old aggregate which has already been used. They have served their life. So obviously result will fall. Means we are not having improvement, improvement. Then let's go. In here also, water absorption capacity. So the more the water absorption capacity, the bad, worse are the aggregate. So you can see when we are adding RCA, water absorption capacity increasing. Means we are going towards ores. Okay. Then in here, average impact value, it's like improving a bit, means again worse, bad. Okay, that means when we are adding recycled aggregate, we are not having anything good. Still we are thinking of using it. Why? Because we need to go for waste utilization and to achieve the circular economy. In here also the same thing. So based on our findings, what we can say, we need to optimize the proportion of RCA with the virgin aggregate. Okay. So maybe not for important some crucial project, maybe we can use it for some village road preparation, village road construction, where there not that strength is required, not that important to those projects. Okay. So the findings of the study highlight the influence of RCA on the various properties. That is what we already discussed. And main conclusion is that optimizing the use of RCA aggregate in sustainable construction method while maintaining the intended performance and longevity of the structure requires an understanding of this effect. So research has been started, yet to minimize to go, then only we can find something fruitful. So for now, we're in the middle. So that's all about our research, and these are the main references we are going through still now. And that's the end of my presentation. This is me and my guide, Professor Dr. Sridevi, Guda Sridevi. She is our Vice Chancellor, means Pro-Vice Chancellor at CGU. And this is our leading student, Kaushik Kumar. Okay, so that's all. So open for question. You can question me to embarrass me. No problem.
It's not like that, sir.
Actually, we are into it. It is not decided. I told you we are doing basic characterization. So after doing some rigorous, some more research, we can come to the conclusion. Sorry, sir.
Sir, at this point of time, what is the novelty you want to show through your presentation?
Novelty, that's actually we are trying for using this RCA, which is now going to be hazard for the society, demolition waste. So what are the various options for utilizing this demolition waste? So we have started newly. So in terms of novelty, I should not
at
say.
At this point of time, it's in infant stage. Later on.
Yeah, we cannot make that big statement. Novelty.
Yep.
So,
thank you.
So would you like to continue with your second presentation?
Yeah.
Too? Okay.
Let me finish.
Okay. He will continue with another PID 1207, that is on the topic settlement behavior of bentonite clay in highly saline environment.
Photographer, मेरा फोटो नहीं ले रहा है. Yeah, yes, sir. Please. Yes, recycled. Yes, whole building. For now, we have started with concrete, but might be from road metal also. Yeah. Yes, mixed material, but yes, we are first characterizing. No, for now, separately we are using. Say, for example, from concrete, whatever we are getting, separately we are doing. Then from road, separately we are doing. Then we will think of mixing, if something good we get. But always we are getting some, inferior result. So there might be some always optimization thing. And might be we have to mention the specific project where we can use without any hazard or insecurity and factor of safety kind of thing to avoid the risks. Yeah. So actually just we have started, we need time. So this is my second presentation, okay. So this is regarding geotechnical engineering, settlement behavior of bentonite clay in highly saline environment. Where there is saline thing means some salt will come, right? So again I came for on behalf of Mahapatra, Sheetal Mahapatra. So let me go. So the soiling and settlement properties of bentonite clay become highly complicated when it comes. Yes, that is what I should do. Then we have gone through some literature and we have found something to do. And this is our scope. We have calculated or estimated some relevant parameters like concentration coefficient, compression index, then compressibility coefficient, those things, okay. And these are the mixed matrix we have used along with the salt. Then this is the methodology, and this is how we developed our setup for our experimentation research, and we got some results. Then this is the result, as you can see. So our result actually matching, or the pattern is similar to previous research done by Datta and Mishra. So it's going good, but they did it for different salt, magnesium chloride. We are doing for sodium chloride, that table salt. So you can see some improvement we are having. So when we are using salt, actually we are having some good result. Means that settlement behavior, compressibility behavior is getting reduced, mitigated. So if we use salt in bentonite clay, then it's good to avoid the settlement of foundation beyond its allowable limit. So far that's what we got. So that is our observation actually. So thank you. Sodium bentonite. Yeah. Sodium bentonite, sir. You know, and also we are thinking for that black cotton soil. We have it in our lab, but we are just started with this bentonite, because bentonite is more soiling than black cotton soil. So let us first see the bentonite, then we'll go. So again, this is the research we have started. Sheetal Mahapatra is our newly admitted PhD student. So that's all. Yeah, we included. So that's all. So any question if you have? So that's all. So I love you. I love OP.jindal. Okay, thank you for giving the opportunity to come here. I was thinking for long to come here. So after that long time, today I came. So I love OP.jindal. Okay, thank you.
Thank you, sir. Now the next presenter is Pratyush Kumar Goyal with PID 1267. He is going to present on the topic Performance Assessment of Sugarcane Bagasse Ash Blended Cement Mortar for Sustainable Construction Practices.
दिख भी नहीं रहा। Yes. Good afternoon to everyone. Myself Pratish Kumar Goyal, PhD scholar from NIT Raipur, under the guidance of Dr. Meena Bru ma'am. My research topic is on performance assessment of sugarcane baggages, blended cement mortar for sustainable construction practices. These are my contents here presenting. First, discuss about the introduction part. These are my contents, and this is the introduction part. In the construction industry, yes, sir. Sorry. काम पे ना, sir. This is the introduction part, sir. These are my objectives. है ना? Objective is that first objective is that about the to evaluate the physical, chemical, and microstructural properties of sugarcane baggages through SEM and XRD analysis, so that it's determine its suitability as a supplementary cementitious material. Second objective is that about the replacement of sugarcane baggages as a partial replacement of cement by interval of 5 to 30%. And then also give results about the fresh properties including consistency and setting times of cement paste. Third objective is discussed in the mechanical performance and durability properties. And at the last, we have concluded that the how much optimum replacement percentage gives better strength and durability properties. These are the materials used. First is OPC 53 cement used in my research work. Second is sugarcane baggages, which is collected from Adanteswari Sugar Factory, Karkapata, Valod. After treated, we have used. And third is river sand, natural river sand. And last one is potable water. Some discuss about the sugarcane baggages. This is my main material. This sugarcane baggage is industrial byproduct derived from the substantial fiber waste material that constitute around 30 to 34% at the weight of freshly harvested sugarcane. The extraction of sugar from the sugarcane, large fiber waste product is often called baggage. And in the flow chart, we have seen that how sugarcane baggage is generated. Because of this more amorphous silica, it shows a good pozzolanic properties. So makes a suitable cement replacement material in concrete. These are some physical properties and chemical properties. We have seen that in physical properties, specific gravity of OPC cement is more than SCBA because of OPC is more denser than SCBA and also more lightweight of SCBA. And in chemical property, we have seen that silica content is more, so that we have used in our research work. This is a methodology we have prepared for testing. First, in table we see that in the interval of 5 interval we have used for SCBA replacement. And water content in this each mix was determined based on standard consistency. And for compressive strength test, mold was for mortar test 70.6 mm. And compressive strength test after 3 days, 7 days, 28 days of curing, and durability test was conducted after 28 to 56 days of curing. Here some characterization of sugarcane. First, here we see that from same images of sugarcane baggages, various morphologies and various shapes of particles like a prismatic particle, spherical particle, irregular particle, and fibrous particle. This particle makes good binding for good pozzolanic material and good finer end in concrete. The SRD test results, we have seen that in SRD test results of ACBA, we have seen that two types of amorphous phase and crystalline phase. The crystalline phase consists of quartz and calcite and silica hump at 20 to 25 degrees centigrade, 20-25 degree at 2 theta angle. Then consistency of cement with sugarcane bagages test results. We have seen that when replacement of sugarcane bagages increases, then consistency of cement paste also increases because of ACBA have a more porous structure, porous particles. In initial final setting time of cement, we have seen that also when increases the replacement percentage, both initial and final setting times increases. And in compressive strength test results, we have seen that after 3 days, 7 days, and 28 days curing, optimum cement replacement, optimum percentage of 15% gives better strength because of more finer and dense particle effect of fine ACBA particles. This water absorption also gives more water absorption at 28 days and 56 days. After long curing periods, water absorption is minimum. This acid test results. After in conclusion, we have concluded that for same analysis of ACBA microstructure reveals that various particle shapes with porous and rough surfaces, and this characteristics increases its surface area and reactivity. From chemical analysis, we have seen that more amorphous silica. We have we identified that it's a good pozzolanic materials. From incorporating ACBA and increases both the initial and final setting times when increases ACBA replacement percentage. In terms of compressive strength test results, 50% ACBA substitution gives better strength, and in terms of durability test results show that ACBA mortars exposed to acidic conditions undergo strength and mass loss, indicating that the presence of non-reactive ACBA flashes can negatively affect performance in acid-prone environments. So we have concluded ACBA is a good material for replacing in cement, and also is for make sustainable concrete. These are my references, and thank you, sir. So any questions?
Okay, Pratyush, just one question. A very nice presentation. So out of your 6 mixes which you have shown,
yes,
so which will you recommend for the use?
Yes, sir. For 15% replacement, it gives better.
So you are saying M3 is the best mix,
yes,
out of all those 6?
Yes.
For all the experiments what you have performed?
Yes.
Okay. Thank you.
Thank you. Now, the next presenter is Sri Kulshresht Singh with PIT 1227. He is going to present on the topic Adaptive Air Quality Management in Mines via Real-Time IoT Sensing Networks. Please, sir.
अच्छा ठीक है अच्छा ऊपर वाला ये वाला ना ओके ये हाईलाइट है ओके ओके ठीक है ओके हाँ ओके ओके सर
Good evening, everyone. I am Kulsresh Singh, Assistant Professor from Department of Mining Engineering, OP.jindal University. And today I will be presenting our research work on adaptive air quality management in mines via real-time IoT sensing networks. And this work has been carried out in collaboration with my co-authors, Mr. Abhishek Vishalkiran, Mr. Ritik Agarwal, Dr. Sivta Mukhopadhyay, Dr. Indranil Banerjee, Dr. Ashish Sahu, and Dr. Gagan Gupta. So let me first get to the introduction of this research work. So underground mining is a critical industry, but it comes with significant environmental and health challenges. Some of the sources of air pollutant in underground mines are like diesel powered equipment, blasting explosions, explosives, and some of the other sources of air pollution such as the dust from drilling equipments and the material handling. So basically, the main objective of this research study is the novel real-time monitoring and prediction model that can track mine air quality continuously and also forecast its behavior in advance. And traditionally, monitoring is carried out manually and at intervals, which means delays in detecting dangerous conditions. What is needed instead is a continuous automated and predictive system that can not only measure but also forecast pollutant levels in real time. These are some of the literatures that we have gone through for the research work, and some of the findings and the proposed work are already written here. So let me come to the next slide, which is a methodology. In our methodology, it integrates the IoT sensors, IoT-based data collections with machine learning for forecasting, and the IoT sensors continuously recorded the environmental data. This IoT hardware that you have seen in this diagram is a patented device that you have installed in the Kandri and Munsar manganese mines in Nagpur district, and the IoT sensors continuously recorded the raw data, which then processed and fed into multiple machine learning models. That machine learning models is the linear regression, k nearest neighbor, decision trees, random forest, multi-layer perception, ADA-boost, bagging, and XG-boost. And to improve reliability, we use an ensemble averaging approach, which integrates outputs from all these models and produces a final prediction that is more accurate than any single model alone. And here you can see these are the analytical approach, that is the mathematical calculations as per the standard equations comes from the ASTRO standard 55. The equations are actually adapted from there. First one is the mine air quality score calculated from pollutant concentrations using a linear scaling method, and the second one is the comfortability index for underground work based on temperature and humidity conditions. Third one is the underground mine environmental score. Okay, sir. G. And a weighted combination of both MAQS and CIUW of the 30%. So here is the indices which are the actually depend upon the optical comfort, satisfactory, average, suboptimal, and the unsatisfactory comfort of the indices value of the MAQS and CIUW. So here it is the results and discussion of my my research work. The result achieved of the ensemble model demonstrated that accuracy of the 96.5%, precision 97.2, recall 94.8, and F1 score is 95%, which is the best result as compared to the other individual learning models. Here, these are some of the performance matrices of the different machine learning models and the standard deviation plot of machine learning models that we have used for the predictive algorithms. So, in my research work, to conclude, our research presents an integrated IoT and machine learning based framework for underground mine air quality management. It not only measures air pollutants continuously but also predicts future conditions with high accuracy. This approach is practical, scalable, and can be applied to mines across different regions. So some of the references are shown here, which are used for my research work. Thank you. So open for any questions. Okay, thank you.
Thank you, sir. Next we have Mohammad Parvez Alam with PIT 1041 on the topic Micromechanics and CLT approach to predict elastic constant of fiber reinforced composite. Please, sir.
ये वाला पॉइंटर है, ये दोनों स्लाइड चेंज करने के लिए है। पॉइंटर को प्रेस करिएगा तो हो जाएगा।
नहीं, पॉइंटर की वैसे जरूरत नहीं पड़ेगी।
Good evening to everyone. My name is Mohammad Parvez Alam, research scholar at IIT Raipur. I am here to present my topic, micromechanics and CLT approach to predict elastic constant of fiber reinforced polymer composite, a comprehensive review. These are my table content, and we are starting from the introduction. What is a composite? Composite is the combination of different type of fibers and different type of fibers and matrix. This is the conventional approach to calculate the elastic modulus of composite, and this is the new approach, reverse calculation of lamina elastic properties. In this approach, we are first calculate the modulus of elasticity of different fibers used individual, and then we are going to laminate. And in this method, first we are stacking the different ply and calculate the modulus of elasticity of all the plies individually. Then we are calculate the total modulus of properties, elastic properties of stacked composite. First, we are starting for micromechanics approach. There are some micromechanical approaches. These are some micromechanical approaches. First is the rule of mixtures. Rule of mixtures. From this model, we are calculate the elastic properties like modulus of elasticity, shear modulus, and Poisson ratio, which is the help to predict the strength as well as shear resistance capacity of the composite. And this is the inverse rule of mixtures. This is also called as Rees model, and this method is based on the isostress. That means that is equal stress on the overall fibers. This is the semi-empirical method helping Psi models, and this method is help to also calculate the elastic modulus, shear modulus. But in this method, we are calculate longitudinal as well as transverse modulus also, and this gives accurate value of elastic properties as compared of rule of mixtures and modified rule of mixtures. And in this models, we are used shape factor that is depend on the packing of fibers and geometry also. This is the Mori-Tanaka method. This is the elasticity based model, and very accurate and give very accurate and efficient value of properties. This is the classic laminate theory, and this method is totally based on the laminate. From micromechanics, we are calculate only properties of lamina, but in case of classic laminate theory, we are calculate the properties of stacking or total composite laminate. These are the other applications we are used to calculate the properties as well as strength of composite. And these are the comparative analysis of micromechanics and CLT method, as I am earlier explained. This is my conclusion. Based on my review, still some of the models I have reviewed, but based on this review, I am conclude micromechanics or CLT method both are when we are use both the methods, then we are calculate the first properties of fractions, fiber fractions, and calculate the properties of lamina. Then we are also proceed the calculate of properties of stacking or composite
composite. First we are work on the micro scale, then meso scale, and also macro scale of composite. This is my Fisher scope based on the reviewed. This is the reference. Thank you, sir.
Okay, thank you, Parvez. I think it's just a review paper.
Yes, sir.
Just a suggestion. Even in the review paper, you can add some graphical representation.
Okay, sir.
Between the review, so that it will
Yes,
be
sir.
easy for the audience to understand what exactly you're going to show it.
Yes, sir.
Rest all good.
Okay, thank you, sir.
Okay, thank you. Next we have Mr. Suresh Kumar Paul. He is going to present on the topic encourage systems and their influence on flexural behavior of FRP, strengthen RC beams, a review with PID 1161. Sorry, 1166, you mentioned 1161 here.
Good evening, everyone. Myself, Suresh Kumar Paul, research scholar from NIT Raipur. Today I am presenting my review paper, Anchorage System and Their Influence of Flexural Behavior of FRP Strengthened RC Beams, a review. These are the contents of my presentation. First, introduction, why we need strengthening of RC structure. Because reinforced concrete structures are backbone of our global infrastructure. It is degraded due to the environmental exposure, increased service load, design deficiency, and involving design codes. For this, we have necessity of effective strengthening and rehabilitation strategies. Next, sorry. For this, we have the steel plate bonding, concrete section alignment. In this, FRP is a superior alternative traditional method for strengthening. It is the key advantage of FRP is the high strength to weight ratio, superior corrosion resistance, minimum disruption during application, and high design feasibility. But the FRP strength and RC beam subject to the various failures like FRP debonding, concrete cover separation, intermediate debonding. For that, FRP often separate from the concrete surface before reaching its full tensile strength. This premature debonding prevents full utilization of FRP. It results reduced flexure behavior, capacity, lower ductility, insufficient use of expensive FRP material. So anchorage systems are required to control debonding and enable effective FRP utilization. The first failure is in debonding. In this debonding, the debonding starts from the end of the FRP plate due to the high interfacial stresses and propagates towards the center of the beam. Next failure is concrete cover separation. It begins with the flexural shear cracking near the plate ends, and it separates from at the level of concrete and the steel bonding. And FRP, during the delamination of FRP, some concrete material is attached to the FRP sheet. It is shown in this figure. This concrete material is attached to the FRP sheet. Next failure is intermediate crack debonding. It initiates at the flexure or shear cracks in the high moment region. In this region, the cracks will develop and propagates rapidly along the FRP concrete interface towards the ends. It occurs at this point, and the delamination towards the end of the FRP sheet occurs before the FRP reaches rupture strain, underutilization of FRP strength. And next failure is FRP rupture. Occurs when bonded FRP reaches its tensile rupture capacity, represent the ultimate limit state and full utilization of FRP strength, and it is less common debonding failure, and it is effective stress transfer and strengthening when achieved. This is the failure mechanism of FRP rupture. Now, for the mitigate this debonding, we have some anchorage systems. First one is FRP U-jacket anchors. This figure shows how the FRP U-jacket wrapping is applying on the RC beam. Fiber strip wrapped around the soffit. and the sides of the beam, and it prevents the premature debonding and confinement shift failure from concrete cover separation to FRP rupture. And it is various means inclined and X-shaped jackets and pre-steer jackets improve confinement. Next one is mechanically fastened metallic anchors. Steel plate, bolts or clamps fix FRP laminates to concrete, provide mechanical resistance against spilling, enhance stress transfer beyond the adhesive bonding. This figure shows the steel plate bonded to the concrete soffit, beam soffit. It prevents the debonding of the FRP. And next one is FRP spike anchors, bundle of carbon or grass fiber inserted into the drill holes in concrete, fan or FRP surface. This is the two components of the FRP fan anchor, one anchor fan and second one is the anchor dowel. This is inserted to the concrete substrate or soffit of the beam, and this is the this fan spread stress to the reduced concentration. This improve bond performance, delayed illumination and enhanced ductility and load capacity. Next one is pi anchors. Actually this is this picture shows like pi shape, that's called, it is called as a pi anchors. It provides the mechanical connection between laminate and substrate. It prevents debonding also, and benefit of this superior bond efficiency, enable higher load capacity and rupture based failures. And for the performance, from the literature I found that the UREF increases the shear strength up to 76%, ductility up to 172% compared to control beam, and failure pattern shifted to debonding to rupture, and improved serviceability when combined with compression FRP layers. In spike anchor, it is also increase the load capacity and ductility, and is useful for the retrofit in hard to reach zones limitation. It is in a spike anchor, the main failure is risk of the pull out of the failure, means the dowel bar is pull out from the concrete substrate. And next one is the metallic anchors. It is also yes. So anchorage system in the FRP strengthened beams or anchorage system are fundamental in improving the FRP strengthening efficiency. It prevents premature debonding, and techniques such as URES, metallic fastener, spike anchor and pi anchors all are used in due to mitigate the debonding. It increases the load capacity, ductility and strain efficiency, but some challenges are there. Pull out of failures of spike anchors, corrosion risk in metallic anchorage and installation difficulties. And some of the future direction for this research, standardization of design guidelines, optimize anchored configuration, and long-term study of the environmental study and cyclic loading for the anchorage system. So anchorage system are the key and safer, most effective and sustainable strengthening solutions. These are my reference. Thanks.
Hello. How to ensure bondage between that fiber plate and homogeneous concrete material?
In practically, sir?
Yes.
Actually, we have used epoxy for the bonded between the concrete and this FRP layers. To increase the, means if beam is insufficient in flexure strength, then we have to bonded the FRP sheet in the soffit or the beam.
What are the dimension of that fiber sheets?
Dimension, if we use wrap, yes sir.
Thickness.
Thickness is 0.111 mm.
0.111.
Yes, sir. For wrapping, if you using plates, but it is more, if you use plates, so it is more successful to debonding.
Okay. Have you done that cost calculation for normal beam and the
No, sir, not done the cost calculation. I am doing the experiment for the, my major research is on the delamination failure, how it will be prevent, and how to utilization of FRP sheet to increase using the different anchorage systems.
Instead of that fiber plate, can we have more number of tensile reinforcement at bottom, so that can be utilized for both purpose as a tensile as well as a fiber layers?
Yes, sir. We can use plate also, but plate is if you using plate, now debonding failure is it is more means कि if you using plates ना तो debonding failure ज़्यादा हो सकता है सर, पहले हो जाएगा.
Desired failure.
Yes sir.
You are whatever you are expecting that that should show a desired failure mode, na?
Yes sir.
It should not be a sudden one.
Yes sir.
It
should not sudden. We wanted कि it is fail in FRP rupture, means कि it will break after the 100% utilization of its strength, axial strength. We are using unidirectional sheet.
And one more thing, there may be a reduction in cross-sectional area of beam if we use this plate.
Reduction in
cross-sectional area.
Yes sir, but compared to the section enlargement, means कि if you using the extra reinforcement and concrete, it is a lesser thickness than the.
No. To transmit the same amount of load, we are going to design one conventional beam and one with the FRP plate.
Yes sir.
Okay. So definitely the cross section of this FRP beam will be less because we are adding some strong material.
Yes sir. Yes.
Below that, na? Okay. Okay.
So percentage elongation you have mentioned, that is increasing probably 176%.
Yes sir.
In your slide.
It is.
So can you justify that? How it is possible?
Actually, I have gone through some literatures, and they have experimental investigation on the anchoraged and non-anchoraged beam. Compared.
That is correct.
Yes.
But whenever you are talking about 100%, that is the maximum.
Yes sir.
So how it is going to 176?
It is mentioned, sir, in the literature.
No, you have to justify that proper way, na? Whenever you are writing anything,
yes,
okay, so you must know that thing. So why this is coming?
Okay,
see, whenever we are measuring elongation, that is a specific elongation for the base material. So you are using concrete. So it can go up to, for example, say 4%, okay? So whenever you are adding anything, it may go to 4.1, either 4.2. So before going to that 4.1, it will break. Okay, so why and how this more than 100% it is coming? So you must justify that thing.
Yes sir, I will
okay.
check.
Thank you.
Thank you sir.
Thank you. Now we have come to the last presentation of today's technical session by Dr. Jayashree Mohanty, having PID 1208. She is going to present on the topic preparation of ferroalloy through electrochemical route from industrial waste. Please, ma'am.
आपका ये माइक लगे मैम, ये पॉइंटर है, हाँ ठीक है, हाँ, और ये स्लाइड चेंज करने के लिए.
Yes. Good evening to all. So myself Dr. Jayashree Mohanty. I am going to present my presentation regarding preparation of ferroalloy from different industrial waste through electrochemical route. So as in the today's talk, many speakers have that is emphasized on the industrial waste, how it can be utilized or any kind of value added utilization can be made from the different industrial waste. So I'm just going through one of the utilization of industrial waste like slag, iron slag, and red mud, which is one byproduct or the waste generated from the bauxite mining. So the first one is, that is ilmenite. We know it is a very popular mineral available in Odisha as well as India, very abundantly available, and it is the chemical composition is FeTiO3 that consists of iron oxide and titanium dioxide. So what happens when after removal of the iron from the ilmenite, the byproduct is that is the titanium slag. We cannot say it as the waste, but because it is a source of the titanium dioxide production, it is simply one byproduct. And this byproduct is a very great source for production of iron titanium alloy. As you know, this iron titanium alloy is very important material for steel purification or steel oxygen removal. That is, it is useful in the steel industry. Okay, so that's why, and apart from this, the alloy is also useful for hydrogen storage material. So now looking at its composition, we can think that this material can be used as a source for the iron alloy production. Now the second waste or the byproduct we are discussing is the red mud, which is the byproduct of the bauxite industry, that is after removal of the alumina from the, that is the bauxite, the residual part is the red mud, and the maximum part of this byproduct is iron oxide. And apart from this iron oxide, it also contains titanium dioxide, aluminum oxide, silicon dioxide, and other kind of oxides are also available. So now our main objective is to utilize these two types of solid waste or byproducts for producing the different types of the iron-based alloys. Now, if we can go through the literature, we can find that most of the iron-based alloys are produced through the carbothermal reduction or metallothermic reduction. However, another kind of reduction we can prefer, that is called electrochemical reduction. And we know that very popularly the aluminum is produced through electrochemical method. And what is the benefit of using this electrochemical method is they are quite, that is environmental friendly, and it uses the green reagent, that is electron. Second thing, the product purity is comparatively higher than the other kind of reduction processes. So we prefer here to produce these alloys through the electrochemical route. So now I'm going to describe the process in a very brief manner. You can see here, usually as per our common knowledge, whenever if you consider the aluminum extraction, usually we dissolve the alumina, Al2O3, in the cryolite, and we produce the aluminum at the cathode. But here we are not doing such kind of things. We are not, that is, dissolving the metal oxides into any kind of electrolyte. Rather, we are taking the metal oxides directly in the solid form as a cathode material. And at the anode, we can use the inert anode, and you can also use the carbon anode. And ultimately what happens, whenever we are applying a certain potential and taking one electrolyte based on molten calcium chloride, we can deoxidize the solid metal oxide electrode. So overall, we can say So overall, we can say that the reaction is, if you can say this is the metal oxide, it takes 4 electrons to produce the final metal, and at the anode, the carbon reacts with the oxygen that is liberated at the cathode to produce the CO2. So with the subsequent electrolysis, continuous electrolysis, the metal oxides liberates the oxygen, and at the end, the whole metal oxide is converted into the metals.
Sorry to interrupt you, ma'am. Ma'am, we are running out of time. Request you to kindly wrap in 2 minutes.
Yes. Now, this is one example. How can you do it? We have taken one powder of metal oxides. We can make it in the cathode form, and we have connected with the electrode, that is a a metallic conductor, and we will make it as the cathode material, this system. And the overall, that is the procedure is this one, the schematic diagram, experimental setup is like this. This is the molten electrolyte, and this is the cathode material. Here the oxide cathodes is there, and during the electrolysis, the metal is completely reduced, and it is one example of production of titanium metal from the TiO2. And this is one where we have taken directly the slag material as the cathode material. We have not done any processing. We take directly the piece of the slag material and make it as the cathode, and we have completely reduced it into FETI alloy, and these are the characterization result of this FETI alloy, showing the production of the FETI phase along with the titanium phase. And very most importantly, the other impurities like calcium and magnesium, they are removed from the, that is a source material, source oxide, into the electrolyte so that we can get the desired alloy powder. Similarly, we can process the industrial waste like red mud in the similar manner to produce this iron alloy having this type of compositions. And these are the this is the initial red mode, and this is the iron alloy after electrolysis, and after water washing and grinding we have got such kind of powder. And the major benefit is this powder can be used for its end applications to enhance to produce different kind of advanced materials like aluminum metal matrix composite or polymer composite to increase their strength. Also, many people have said many things regarding the how to develop how to strengthen the concrete properties. This can be one of the opportunities where we can use this kind of alloy powders to the concrete materials to enhance the overall properties. So, at last, I will thank the Taxman Foundation, ISM Dhanbad, for funding DST Government of India for funding to carry out the work, and C.V. Raman Global University. Thank you.
Thank you, ma'am, for your nice presentation.
Thank you.
I have a little doubt.
Yes.
So red mud.
Yes.
Is it acidic or alkaline?
It is alkaline.
What is the alkalinity means pH value?
It is around 8 pH coming.
No?
Yes, it depends whether whether they are processed it, because sometimes they actually, it is not the rule that you will throw directly to the environment. Yes, but whenever you take that is some slurry of the red mud, it becomes alkaline.
Yes, yes. So it is collected from where?
Damanjodi.
Okay, okay.
Yes.
So what ratio you have used when you have measured that pH value? Ratio of water and red mud.
It is?
Ratio of red mud and water.
Yes, yes. No, I have not that much, I have not measured, because my aim is, in my experiment, actually the alkalinity does not affect the overall property. Yes, yes, yes.
So you don't bother.
As I am saying, the sodium, calcium, magnesium, alkali and alkaline earth metal, those were present, they are removing during the electrolysis. That's why I am not bothered about this alkalinity.
But now red mud is becoming biohazard.
Yes.
Lot of red mud.
Yes, yes, yes. But I can use it directly. Yes.
So thank you, ma'am. Thank you for a nice presentation.
CaCl2 and CaO. So actually there are two types of electrochemical system we can take. In some system, people are preferring to use CaCl2 and CaO mixture. Their objective is to deposit calcium from CaO, because what potential we are providing, that is the decomposition potential of CaO, but the potential is less than the decomposition potential of CaCl2. So when they are decomposing the CaO, it will produce calcium, and calciothermic reduction takes place along with the electrochemical reduction. But in my system, I have never taken the CaO, I have taken only the CaCl2, where the reduction is only taking place by the electrochemical reduction. And if there is some amount of calcium is there, then partial calciothermic may take place, but predominant reduction is electrochemical reduction.
Is it economical as compared to metallothermic?
Yes, if I will compare the preparation of iron alloy from red mud, we have calculated some of its calculation, energy consumption likewise. It is economical, and we have used it for preparing the aluminum metal matrix composite. Its hardness is around, that is mechanical properties is increasing around 60%. Very significant increase, and also it is retaining its ductility, also a very important factor. It is maintaining the ductility in contrast to the ceramic reinforcement. So we are hoping that we will use it in the further study in concrete materials, what it is affecting.
Okay, thank you.
Thank you.
Thank you, ma'am. Now it's time to honor our presenters. For that, I would like to request Honorable Vice Chancellor OPJU, Dr. R.D. Patidar sir, and respected Registrar, Dr. Anurag Vijayvargiya sir, to please come on the stage and distribute the certificates to our presenters. Please, sirs. Dr. Arka Ghosh. Dr. Jamarul Sheikh. Mr. Kaushik Kumar. Mr. Pratyush Kumar Goyal from NIT Raipur. The previous presenters were from C.V. Raman University. Mr. Kulshresht Singh from OPJU. Mohammad Parvez Alam from NIT Raipur. Mr. Suresh Kumar Paul from NIT Raipur. Dr. Jayashree Mohanty from C.V. Raman Global University. Mr. Manas Behra from C.B. Raman Global University. Mr. Prakash Singh Bagga from SRP Private Limited. All the presenters are requested to please come forward for a group photograph. So please stay back. Bagga sir,